Hi there, this is Mar Haddad here. In the first section of this course, I have to discuss about what is VLAN and why is it important to have VLANs in our network. So I'm going to speak about what is the main reason to have VLANs on our network, and then I'm going to show you what is the definition of the access port, the trunk port, and of course I'm going to show you how you can have that in a network. So in this section is nothing more than explanation about VLAN. I'm not going to do any lab for now. So it's very important first to understand the VLAN and the trunk and the access port. And then after that, when we understand this, we can apply it on the MikroTik routers, creating the VLANs, which we can do it on different ways. So this is what we are going to do in the first section, only understanding the VLANs. So what is the VLAN and why we need to use it in our network? And after we finish that, we will start applying this on our labs. So let's go directly for the explanation of the VLAN. Hello everyone, this is Mar Haddad here again. In this lecture, I'm going to explain to you about VLAN. So what is VLAN? How does it work? What we need to do in order to configure VLAN in our network? And of course, we are going to see what is the benefit of using VLAN in our network. So this is what I'm going to do in this lecture. I'm not going to do the lab now. The lab will come after this lecture directly. So now let's go and check what is VLAN and why we need to have VLAN in our network. Okay, to make it easy for you, I just make a drawing here to explain to you how we can apply VLAN inside a company. For example, let's say we have this company here, and this company consists of 3 floors. Floor number 1, first floor, second floor, and third floor. In the first floor, there are 3 computers connected to this switch. On the second floor, there are also 3 computers connected to the second switch, and on the third floor as well, 3 computers to the switch, and then all switches are connected to each other via one switch. So in this case, we have one network where the 3 floors are connected to each other. Okay, so if we don't use VLAN, this is what we normally call a flat network. Flat network means that we have only one network, which is like you see here. This is the whole network that we have. Okay, and on this network, all computers are able to communicate to each other. Okay, so in this case, we only need to provide one network ID. So I'll put here network IDs. For example, we say here we will give to this network 192.168.0.0/24. That means this computer, for example, the first one here, he would take 192.168.0.1, this 192.168.0.2, this 3, 4, 5, and until .9 here. Okay, so you will see that all are on the same subnet, and that's something we will have problem with that, especially when we need to divide our network into different departments. Okay, we will see it in a moment, but the idea is that every computer will be on the same network. Then if we go back to the network basics, and we know that one computer, when he wants to communicate to another computer, he needs to have the IP and the MAC address of the destination computer. That means the computer that he needs to send to him his frame. So in this case, let's assume that computer 1 would like to speak to computer 9. So he will check, okay, I have the source and the destination. So the source MAC and the source IP, which is his own MAC address and his own IP, he has them because it's for him. But he will see that he's missing the MAC address of the destination, but he has the IP of the destination. So he knows the IP of the PC number 9, but he doesn't have his MAC address. In this case, he needs to do a ARP request. That's something we go back to the network basics, and ARP request is exactly when he would like to know the MAC address of the destination. And also from the network basics, we know that ARP is sent via, if you remember, broadcast. Okay, so there will be a broadcast. And broadcast is very bad for our network because in this case, our network will not be working anymore. It will not be functioning anymore. That's broadcast. So the ARP request is sent via broadcast. That means when computer 1 is sending the ARP request from here, it would come to this switch. And this switch will send it to all ports that he has, because it's a broadcast. You don't know where it's going. So we send it to all ports that he has active, and not only from the port that he received from it. So he received this ARP request on his port. He will not send it back because he received from that, but he will send it from here he will send it from here, he will send it from here. So it goes to computer 2, computer 3, then it goes here, it will send to here, and to this switch send it here, 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 and also it will go to this switch, and this switch send it here, to here, to here. So you can see that because we are in a flat network, then the broadcast is sent to all computers and all our network, and this is causing problems to our network. So this is what we call in the flat network, we have a one broadcast domain. Okay, one broadcast domain. That means that the broadcast is sent to everyone in the network. So it's one domain. Okay, so you can see this is one broadcast domain. So the whole network here is a one broadcast domain. So this is one problem of the flat network that we can see now, that in case there is any broadcast, and in the network there are a lot of broadcasts. You can have ARP requests, you can have DHCP requests, you can have many other type of protocols that needs broadcast. And then in this case, every time there is a broadcast, the whole network will not be functioning anymore. And that's a big problem that we have in our case. And as you remember, because we are working on switches now, and that's layer 2. And layer 2 doesn't divide broadcast, it only divides the collision. So it can make different collision domains, and the switch can do that. But broadcast, you cannot stop it. It's only the router which can stop it. Okay, so that's one problem that we have. So we say here we have one network ID, and then 2, it's one broadcast domain. And that's another major problem that we have. Okay, now let's check also the third problem that we may have here. But let me first clean a bit the pictures to be able to explain to you the third problem. Now, the third problem that also we may have here is, in case, for example, we say, okay, for floor 1, I want all SACE people to be connected to the floor 1. So this switch here is connecting all computers which are from the SACE department. And we say on the floor number 2, I would like to have the finance. Okay, let me grab another color. So we say here, this is for the finance. And for the floor number 3, we say here we have the, for example, marketing. Okay, so what will happen now that, okay, we divided physically the users which are in each of the department to be connected to each other. For example, in our case, we say floor 1 is SACE. That means all computers which are on the floor number 1, they are from the SACE department. So they are all physically connected to this switch. Okay, and then the same for the finance and the same for the marketing. So here the problem is we cannot apply security to say, well, we don't want the finance department or finance users to get access to the SACE users. Okay, so that means the PCs of the finance to be able to get connected to the PCs of the SACE, because again, they are on the same network, they are in a flat network. So we cannot also apply a security policy here, because at the end they are on the same network, and that's also a big problem that we may encounter, that you cannot also make security. And that's also point number 3, which is that we have problem with security. Okay, so we cannot secure our network and say, well, this department, I would like also, for example, the SACE, to not allow them to do that and that and that, and also allow them to do this and this and this. Same we do on the finance, on the marketing, because at the end, if we want to make a security, it's going to be for the whole network, because again, it's a flat network, it's one network, it's one subnet. Okay, so in this case, we have also problem with security. And the last thing that I want to explain here, this the problem. Let's imagine that we have on this number 3, we said it's on marketing. I will take the green color. And we say that this switch goes off. Okay, in this case, when the switch of the marketing goes off, then the whole network or the whole computers which are connected to this switch, which are the marketing users, they are also not able to work on the network anymore, because the switch is off. Okay, And that's also another problem. So we have a major problem that in case a switch is off, for example, it gets damaged or it's not working or someone took the power out of it, then in this case the users which are sitting inside the marketing department in the third floor, they're also not able to be connected to each other. So there will be each computer a standalone computer. And we know nowadays we really need a lot to have access to the network to be able to make our work. Okay, same applies for the other switches, for the finance or for the SwOS. So that's also, we can say here, one point of failure. So if we go here to point number 4, we can say one point of failure. Okay, and in our case, the whole marketing department will shut down and we will not be able to work in case the switch is off. So these are the main ideas that we have in this case, and we can also add on it one more point. Like, for example, say that the switch of the marketing is working, okay, and we have the network is working, but we need to add one more employee. And on this switch of the marketing employee working for marketing, then this switch doesn't have any ports left to be able to connect to the user to that switch. Then in this case, if we say that only on the third floor are the marketing and we don't have any switch anymore available to have a port to connect to it, then we will not be able to connect them, for example, to this switch or to this switch, because we have defined that the switch of the floor number 2 is for the finance and the switch of floor number 1 is for the SwOS. So we only want to group them physically from the same department. And that's something also a problem that we can name it, because also in this case we need to buy a new switch and we need to have more ports to be able to connect the new marketing guy on the new switch, which normally should be connected also to the switch of the marketing. So these are problems that can happen when we are deploying a flat network. That means one network and all users are on the same network ID. They can cause a lot of problems of broadcast. There's no security that we can assure that each department is not able to see the other, for example, on the network. And then we have one point of failure. So these are the main problems that you can have when you deploy a flat network. So for this case, we need to have VLAN. And VLAN will solve for us all those problems that we just have explained now. So let me now show you, in case we have the same case and we apply VLAN, what will happen and how those problems that we have just mentioned now will be solved. So here is our same scenario. We still have here the headquarters, for example, or the building, and those are the 3 switches connected to the main switch, and they have the users connected to each of the switch. Okay, so instead of saying that floor number 1 is for sales, floor number 2 is finance, and floor number 3 is marketing, what we can do, we can create VLANs. And we can say, okay, VLAN number 10, let me write it on the blue color. So we say VLAN number 10 is for sales. And then VLAN number 20, it is for, we said here, finance. And we take the red one, VLAN number 30, it is for the marketing. So that's something, the VLAN, it's virtual local area network. So that's something virtually. So we still physically, if you see physically, the same computers are still connected physically as it was on the previous case. So if we go to the previous slide, we see that 1, 2, 3 PCs connected to this switch, 1, 2, 3 PCs to this switch, 1, 2, 3 PCs to this switch, right? But in this case also, we can look that 1, 2, 3 PCs connected to this switch and so forth. So all the physically switches are still connected, they are. But virtually we are creating VLAN, and then why we do that? To separate the departments from each other. So we can say, okay, I will create VLAN 10, and on VLAN 10, I will say that this is for sales, and I put the computers on the VLAN. So actually it's not the computer that we can put, it's actually the port which is connected to the computer. So in our case, we say that VLAN 10 is this one, the blue one. So I will come to this switch, I will say this port and this port and this port, I would like to put them on VLAN 10. So when we put the port inside VLAN 10, then directly the PCs which are here connected to those ports, they become like they are connected to the same switch. Okay, so they will be like one network together. All right, so also I will do the same for the, if you can see here, we say, okay, for this port which is connected to this PC here, and this port and this port, I will make them inside VLAN 20, because VLAN 20 is for the finest. And then those computers which are here on the yellow circle over here, they will be inside VLAN 20, and I define that VLAN 20 is for finest. Then in this case, those PCs, they will be working together only. Okay, and same I do at the end for the VLAN 30, and I will say that this port and this port and this port, which are connected to those PCs here. Okay, so I will make those ports on VLAN 30, and I will say that VLAN 30 is for marketing. Then in this case, what will happen, that here all users will be in the marketing, and here all users will be in the finance, and here all users will be in the sales. Okay, so what does it mean? It means like we are grouping the same users or the same PCs based on the function they do, even if they are connected physically to the same switch, but they are not able to communicate to each other. So you can see here that this PC and this PC and this PC, they are all connected physically to each other. You can see here the cable, they are connected physically to each other, but they cannot communicate to each other. Why? Because each of the PCs are inside a different VLAN. And in this case, what will happen is we will solve the problems that we have just mentioned here, which are the network ID, the broadcast domain, the security, and one point of failure. How we can solve the problem? Let's first talk about, we say it first, the network ID. So it's a concept that you have to remember. Each VLAN has a network ID. That means, in my case, I will say, okay, for sales, I will say the network ID will be 192.168.0.0/24. That means this will have 192.168.0.1, this .2, and this .3. 192.168.0. something. For the finance, I will say, okay, for the finance, I will take the range of IP of 10.10.10.0/24. Then in this case, the finance here will have 10.10.10. something. So here is .1, here .2, here .3. Okay, so you can see they are on different network ID. So I'll put here 192.168.0. something. Okay, and then at the end also the VLAN 30, which is the marketing, I will give an IP address to it. For example, 172.16.0.0/24. So here it will be 172.16.0. something. Okay, then here is 192.168.0.1, the 2.3. So that means that each VLAN will have its own network ID, and we solved the first problem that we have seen in the flat network. The second thing is the broadcast domain, that we've seen that it's a major problem on the flat network. In our case, when we are creating VLAN, what happens is that each VLAN or computers which are connected to VLAN, when I say computer, I'm saying host. It can be anything as a network device, okay? But in my case, I just have computers here. So the broadcast domain means that each VLAN will have its own broadcast domain. So for example, let's take the case of the VLAN sales here, okay? So what will happen in case, for example, we said the PC3 want to communicate to PC1 of the VLAN 10, which is the sales VLAN, okay? And he doesn't have the MAC address of the PC1, then he will want to do an ARP request, like we've seen in the previous slide, okay? So the ARP is going to be broadcast. Then the broadcast, it will go from here to the switch. In this case, the switch knows that that's a VLAN, and he will not send it back to this PC here and to this PC. He will not do that. He only see where are the computers which are on VLAN 10, and he will send them. So we see that I don't have here any VLAN 10. So let me send it to the trunk. We will talk about the trunk in a moment. And he will send it to this switch. Then this switch will see, okay, this is a broadcast on VLAN 10. Then I will send it only to here. Also, we will go up to this switch, and this switch also will look and say, okay, this is a broadcast for VLAN 10. I will send it only to here. So he will send them only to, actually, to ports which are on VLAN 10. And in this case, it will send only to the computers which are inside the VLAN 10. So the broadcast is only affecting what is inside the same VLAN. In my case, the finance here, they have no problem. So they're still functioning. They don't receive any broadcast. And the marketing also, they're still functioning. They will not receive any broadcast. And this applies to each of the VLANs. Okay, so again, each VLAN creates a broadcast domain by itself. And when the broadcast is sent from a VLAN, it will not propagate to other VLANs. It will stay inside the same VLAN. Okay, so this second problem is solved. The third problem is security. In our case, as we already have different network IDs, okay, so you have to think they are like different networks. So each VLAN have a network ID different from the other. What you can do, we can apply security very easy. Okay, so the problem of the security also is solved because in this case you are applying security on the VLAN, and each VLAN is representing a department. So in our case we have the sales, the finance, the marketing. So in this way we don't have any problem to make security rules. Okay, so that's also a problem that is solved. And the last problem, we said here that in this case there is a one point of failure. So for example, if we say here that the switch of the second floor goes off, okay, so it's not functioning anymore. Before, in our case here, if we go back here, if the switch of number 2, floor number 2 is off, then all marketing will be not able to work anymore, because that's where we grouped all marketing users on the floor number 2. But in my case here, if I apply VLAN, if I go back here, if we say that the switch of floor number 2 goes off, then what will happen that this PC and this PC and this PC will not work anymore. That's correct, yeah, because they are physically connected to this switch. But it doesn't mean that the whole marketing department goes off. So for example, we can see that those two, they are able still to communicate to each other because they did not get affected. Also for the finance, so they are still able to communicate to each other, the finance. Also for the sales, those two PCs. So we don't have like a single point of failure, like if a switch goes off, then the whole department goes offline. Okay, that's not the case in what we have here. So because at the end, all switches are connected to the main switch, which is here. So this is the main switch here. So in this case, if this goes off, then those two are still functioning because they are connected to this switch. Okay, then also this problem is solved. And one more problem that we have talked about, we said, let me just clean it a little bit. So the other problem, we said that, okay, if this switch, for example, on floor number 3 is full, there is no more place or there's no more ports on the switch to add. And you have a new colleague coming to work on marketing. And I said, well, I want to put it on floor number 3. And then I looked on the switch, I saw that there are no ports left. So that's no problem. Then I will look to other switches. I will check, okay, on switch number of floor number 2, there is a port available here. So what I can do, I can, okay, make here a connectivity to this PC and for this employee. And then I put this port, because he's going to work on marketing, on VLAN number 30. When I put it on VLAN 30, then this computer will belong to this VLAN. Okay, so he will be one of the members of this VLAN, and he will be able to be on the same network where all those computers are, which are on VLAN 30. Okay, so that's much easier when you apply VLANs on your network, and it makes much easier for you to manage your network and to make your network more scalable. Okay, so I highly advise that you don't go to flat network unless you have a really small network, like 10 computers or something. That's possible. But when you have a big network with different departments, then VLAN is always the best solution. So now we understand the concept of the VLAN. I just want to explain now more technically about the VLAN. So what is the access port? What is the trunk port? How we want to create the VLAN? How we can assign the ports and say that this port on the switch need to be on this VLAN and so forth. So let me show you one more slide to explain to you about all technical details of VLAN. So now we know the idea of VLAN. I would like to now explain more about the technical details that is needed to be known in order to be able to configure the VLAN on your network. Okay, so the first thing to understand is that you have two types of ports that you can use on your switch when you want to configure VLAN. You have something we call access and something we call it a trunk. Access, that means what? For example, we came and said that this is VLAN, for example, 10, this is VLAN 20, and this is VLAN 30. That's what we want to do. Okay. So in this case, all PCs here, they should be on VLAN 10. So how to do that? When we say we are going to connect to end users, okay, then in this case we are talking about access. Okay, that means a switch connected to a computer, a switch connected to any network device that's gonna be as an end user. Okay, so in my case, that what I want to do, I will go to the ports where it's connected to this PC here. Okay, and before I go to the port, I of course need to create the VLAN. So first thing, I create VLAN. So VLAN creation. Okay, so I will say, okay, on my network I need VLAN 10, 20, and 30. So I create VLAN 10, VLAN 20, and VLAN 30. And this needs to be created on all the switches that we are going to use. So that means on this switch, on this switch, on this switch, and on the main switch. So the VLAN needs to be everywhere. Of course, depending on what type of switches you are using, you can, for example, if you use Cisco, you can create the VLAN on this switch only, and then the first one you say, okay, here I want to create VLAN 10, 20, and 30, and then it will propagate the VLAN to all other switches. So you don't need to do the work on every switch. Okay, same if you use Huawei as well, switches, this is possible. Okay, but it's now not the idea of how you do it, it's only to know the concept that those VLANs needs to be on every switch that are going to use this VLAN. Okay, so first we create the VLAN, and then second, we assign VLAN to port. So we assign VLANs to ports. Okay, so in my case, I will come and see, okay, on the switch number of the floor number 3, I will say this port, which is in my case, for example, Ethernet 2, okay, I want to put it on VLAN 10. Then this PC becomes inside VLAN 10. Then this port, I want to put it on VLAN 20. Then this port, I want to put it on VLAN 30 because the PC is needed to be on VLAN 30. So here what I'm doing, I have first to make the ports access, and then I assign each port to a VLAN. Same I do on this switch, and same I do on this second switch. Okay, then when we do that work, so for example, we also made this port access, and this port access, and this port access. Then I said, okay, this port is going to be VLAN 10, this is VLAN 20, this is 30. Then also I will make this access, and this access, and we put it on VLAN 10, 20, and 30. Then in this case, we have this scenario that we are seeing here in front of us, that all PCs which are on VLAN 10 that are able to communicate to each other, and all the PCs which are on VLAN 20 are able to communicate to each other, but 10 and 20, they are not able to communicate to each other because they are on different VLANs, okay? Unless you use a router at the end, and that's what we call it router on a stick, but that's out of the scope of what I'm explaining now, okay? So then that's what we need to do. So again, first we create the VLAN, 2, we make the port access which are connected to the host, and then we assign to each port on which VLAN he should be in, okay? And now, because we are using 3 switches and the VLANs are spread into 3 switches, then in case we say that the computer which is sitting here, for example, this one, If you want to communicate to the computer on his same VLAN, which is here, then in this case, the traffic is going from the PC to this switch, and this switch needs to send it to here, and then here the switch will know that he wants to send it to this PC here. So that means we need to do something we call a trunk. So we just talked about the access, now we need to do the trunk. So the trunk is what? The trunk is between switches, like switches which are carrying the same VLAN, they need to have trunk between each other. And why do I need to have the trunk? So when you make trunk, for example, in my case, I will say, okay, this port, because it's connected to switches, is going to be a trunk. This port is going to be trunk. This port is going to be trunk. And of course, this port is going to be a trunk. Okay, so when we say trunk, then in this case, what happened is that inside the trunk link that I'm using on between the switch, the package of each of the VLAN will pass. Of course, you can say which VLAN you want to pass. By default, they will pass all the traffic of the VLAN. That means we will see that on this switch, he will send the traffic of VLAN 30. I'll make it red as it is for the VLAN. Okay, and it will pass also the traffic of VLAN 20. And he will pass also the traffic of VLAN 10. Okay, same for the switch number 2, which is second floor, and for the switch number 3 of the third floor. Okay, so that means the trunk will carry all the package of all different VLANs to be able that this PC at the end here is able to reach this PC. That means that in case this PC wants to send also a frame to this PC, he will send it to this switch here, and this switch has a trunk. Then he is able, we take the yellow color, he is able to send via the trunk the packet to here, the frame to here, and it will receive to this switch, and then this switch, he knows that it needs to go to VLAN 20, then he sends it VLAN 20. Okay, it's only the trunk can carry different VLANs. The access will only carry the VLAN that you assigned inside it. So you say, okay, on this port is VLAN number 10, then it will only send to VLAN number 10. Okay, now this is the difference between access and the trunk, so I can repeat it. Access, when you are connected your switch to a host, and then on this switch you create the VLANs, of course, and then you say that this port is access, and you put this port inside the VLAN, like I explained. The trunk is when you have 2 switches, 3 switches connected or more, and they need to carry all the traffic of the VLAN, then you make it a trunk in order to carry all the traffic of the VLAN. Now, it's very important that when you make trunk, the protocol that is used is 802.1q, and that's the encapsulation. Okay, encapsulation that's used for the trunk, 802.1q. Normally it's called .1q most of the time. And Cisco used to have a protocol called ISL. That's also for trunk, but it's not used anymore. It's discontinuous. Even Cisco took them out from their operating system. Okay, so the standard for trunk that you can see in every switch is 802.1q. Okay, so that means that when you want to configure the trunk, you need to enable the protocol of the trunk, which is 802.1q. That's the encapsulation protocol. So that's in brief what I wanted to explain about the difference of having VLAN and not having VLAN. Of course, now you can say, well, okay, we understand VLAN, but how can we apply that to our scenario, which is distributing internet to customers? So how we can do the VLAN there? And that's something I'm going to show you directly in the upcoming video. I'm going to do a lab, and we will use the same scenario that we were using, but instead of having 2 interfaces going from the main router, we are going to have one interface, and then we create the VLAN, and we will see how it works. Of course, we're going to pass through the trunk and the access and the creation of the VLAN and everything. But it's very important at the beginning, before you start working with the VLAN, so you understand what is VLAN and why it's important to have VLAN and what is the benefit of using VLAN. And then when you have this concept in your mind, then it's quite easy to apply it on the lab. So this is what I wanted to show you in this lecture. I hope that now VLAN is more clear for you and you understand now more why we need to have VLAN. And let's now go directly and start with the lab of dividing the internet to customers using VLAN. Hi there, this is Haddad here again. So now after we have learned what is VLAN and what is the main reason to have VLANs on our network, we have to start doing labs. So in this section, I have to show you how you can create VLANs on the router board itself. So you will see that there is different ways to create VLANs on the MikroTik router boards. And I'm gonna show you all the ways to create VLANs. Actually, you will see that if you have a version of the RouterOS from 6.41 plus, you will be able to do a configuration to create VLAN, which is different than how we used to do it before that version. In addition, I'm going to show you how you can create queue in queue. So that's a VLAN inside another VLAN. So I will explain to you in which cases you will have to create the queue in queue, and then I will show you in a lab how you can configure that, and then with the lab you will understand exactly what we are doing. So this is the mission of this section, to make configuration of the VLANs on the router board and creating the queue in queue. If you are ready, let's go directly and start with the first lecture. Hello everyone, this is Haddad here again. In lab number 5 of this course, I'm going to show you how you can configure VLAN in order to assign for each customer who is getting from you on the DHCP the internet service, to assign for him a VLAN. In this case, you can separate your customers and each customer will be inside a VLAN. So as you can see here, we have 8 points to go through, but before I start going through this point, I would like first to show you what is the lab scenario and what we are going to do in this lab, and then we will come back to the points and we can do them one by one. So let's now see what is our lab scenario. So here, as you can see, we have this scenario here. We have main router is still connected to the internet. And what I need now to do is to connect the main router to a router which is going to be like a switch. Okay, so we are going to make the router as a switch. Of course, in place of this router here, you can put for example, a Cisco switch or Huawei switch or any type of switches that you want which can accept VLANs. Okay, so in my case, I'm going to work only on MikroTik environment. So I'm going to use one MikroTik router and I'm going to make it as a switch in order to accept and send the VLAN to the customers. And we have here customer 1 and customer 2. So the idea is as following. Before, when I was doing the first labs, I was saying that, okay, the ISP getting the internet to the main router, and from the main router, I was going to customer 1 and to customer 2. Okay, and in this case, we said we need 2 interfaces on the main router, and if we have more customers, then we need more interfaces, and this is not possible on the MikroTik. Okay, so now what I need to do in my lab here is, instead of having many interfaces, I'm going to use only one interface on the main router, and I'm going to create VLANs. So I will say, okay, I will create VLAN 10, and VLAN 10 is going to be to customer 1, which has an IP address of 10.10.10. something, and then I'm going to create also on the main router VLAN 20, and that's is for customer 2, which has a network ID of 10.20.20. something. Then what I'm going to do here, I have to create those VLANs on this router. And then when I say on this router that the VLANs needs to go or needs to be on Ethernet 2, so means VLAN 10 and 20 will be on Ethernet 2, then in this case Ethernet 2 will become a trunk port. Okay, so we have a trunk port here. Then what I need to do, in order to be able to carry all the VLANs to the switch, then this switch here also needs to have a trunk port. Remember, we said that the trunk is to allow the VLAN to propagate from one place to another. Okay, then in this case, the VLAN 10 packets, so let's say those are the VLAN 10 packets, okay, and the VLAN 20, which have the blue color, will be able to carry through the trunk to this switch. And then from this switch here, he will receive the VLAN 10 and VLAN 20. Of course, we see that we need also to create those VLAN on the switch. But I'm just explaining to you the idea of this lab. Okay. Then in this case, what we need to do, so we made this port as trunk and this port as trunk. Okay. What we need to do now, we have to say on this switch, the port which is Ethernet 3 here,
on this switch, I want to put it on VLAN 10. And the port which is Ethernet 4, this one here, I want to put it on VLAN 20. So in this case, when the trunk are sending the packets 10 and 20 to the switch will check and see, oh, okay, then for the 10, which is VLAN 10, I will send it from my Ethernet 3 interface, and then this customer will have an IP address here on this interface Ethernet 3 of 10.10.10. something, let's say 254, okay? And then because we have put Ethernet 4 on VLAN 20, then the packets will come here, and then into this interface here will have an IP. Of course, we need to enable the HTTP client. We'll have an IP of 10.20.20.254 as an example, okay? And in this case, you can see that we have separated the two customers, and we can do that as much as you want of customers. Of course, you can create up to 4096 VLAN on one router. So the main router, if you have up to 4000 customers, it's always possible to do that. But what you need here, you need more interfaces on the switch, which is not a problem, because this switch, you can have a lot of interfaces on the switch. Okay, or you can add more switches as well. So this is the whole idea of what I'm going to do now. So the idea is that we have to create for each DHCP, because what we want to do here, so instead of making the DHCP server on the interface, we make the DHCP server on VLAN 10 and the DHCP server on VLAN 20 to be able to propagate the IP addresses to the customers on VLAN 10 and on VLAN 20. So this is in brief what I'm going to do in this lab. It may be for you now not very clear, but that's okay. When we do the lab now, I will go point by point slowly, and I will explain each of the steps what I'm doing, so you'll be able to understand the lab, okay? So let's go now to the points and start with the lab. Point number 1, enable the HTTP client on Ethernet 1 of the main router and check if it's connected to the internet. So what I need to do here, I need to enable the HTTP client on Ethernet 1 of the main router. Why I need to do that? Because when I enable the HTTP client on Ethernet 1, then the ISP will send an IP address with all the information needed, like the default route, the subnet mask, and the DNS server, in order for the main router to go to the internet. Okay, so let's do that. I will go to the Winbox, and then from here, I will connect to the main router. And then from here, I will have to go to IP DHCP client, and then I will say plus, and I will say I want to enable DHCP client on Ethernet 1. I will keep DNS and default gateway, and then I will say OK. And we see directly that it has received an IP address. And now my router, if I go to tools, and then I can go to ping, and I will try to ping the DNS of Google 8.8.8.8, and then I see that my main router now is connected to the internet. Okay, so point number 1, it is done. Point number 2, now we need to start creating the VLANs. Create VLAN 10 to customer 1 and VLAN 20 to customer 2 on the Ethernet 2 interface of the main router. So what I'm going now to do, I'm going to create those VLAN 10 and VLAN 20, and I'm going to assign them to the Ethernet 2 interface, which is the interface going to the switch. And in this case, in MikroTik, when you put 2 VLAN on an interface, then this interface becomes a trunk. Okay, so there is no option that you can say on MikroTik, this interface is trunk like we do on Cisco. You just put 2 VLAN on this interface, then this interface is a trunk. So 2 or 3 more and more VLANs, then always it is a trunk. Okay, so let's do that. I will have to go first to create the VLAN. So first thing we need to do, create the VLAN. Then I will go to interfaces, and here you can have VLAN. And I will say plus. Okay, name, you can name it whatever you like, but always try to name it in order to know that this VLAN is to customer 1, for example. So I will say here VLAN 10, and I will say C1, so I know that's for customer 1. Now here it's very important that you put the VLAN ID. When you say VLAN 10, then it means 10. Okay, so VLAN 10 is here, you have to put 10, and I will put it on the interface of Ethernet 2. Okay, so that's the interface of Ethernet 2. I created VLAN 10. Then I will create also VLAN 20. So I will say here VLAN 20 is to customer 2. Then here the VLAN ID is 20 and it is on Ethernet 2. Okay. So I have created the VLAN and we check what they ask us here. So create VLAN 10 to customer 1 and VLAN 20 to customer, actually should be here 2 on Ethernet 2 of the main router. Okay, so this point is also done. Now we have created the VLAN, but the VLAN until now they don't do anything. Now the VLAN are like interfaces. Okay, you have to think them as like an interface. Okay, so what you need to do now, you have to create the DHCP server on those interfaces, and that comes on the point number 3. Put IP addresses of 10.10.10.1 on VLAN 10 and 10.20.20.1 on VLAN 20. So because at the end VLAN 10 is responsible for customer 1 and VLAN 10 will be the gateway of customer 1, and then the VLAN 20 is responsible for customer 2 and it will be the gateway of customer 2. So 10.20.20.1 is the gateway of the customer 2 and 10.10.10.1 is going to be the gateway of customer 1. So we need now to put the IP addresses on VLAN 10 and VLAN 20. So we have here to go to IP addresses and then I will say plus. And here I say I want to put an IP of 10.10.10.1/24. And this IP address I want to put it on, you can see here, VLAN 10 of customer 1. And I will do the same for 10.20.20.1/24. I want to put it on the interface of VLAN 20 of customer 2. Okay, so we have assigned IP addresses to the VLAN. Why we need to put IP addresses to the VLANs? Because now, remember, when you want to create DHCP server, we said that we need to put first an IP address to the interface where we want to create the DHCP server. And that's something we explained it in the previous labs. Now the same concept applies here. We need to create DHCP servers, but this time I'm going to create them on the VLAN. Okay, so point number 3 is done. We have put IP addresses on VLAN 10 and VLAN 20. Now we need to create the DHCP servers that we need to make one on VLAN 10 and one on VLAN 20 and make the NAT. Okay, so I will go again here and I will say, okay, IP DHCP server. Let me delete those. And then we create DHCP setup. And the first DHCP server, I want to create it on VLAN 10. And VLAN 10 has an IP address of 10.10.10.1, okay? Then the range of IPs should be 10.10, correct? So the gateway is going to be 10.10.10.1, that's fine. This is the IP addresses that we provided, that's fine. And here the DNS, the lease time. So this is the first DHCP server I'm creating, and this is going to be provided to the customer 1. Okay, now we do the DHCP server for customer 2. We have to click on DHCP setup and I will create it on VLAN 20. Then it's 10.20.20.0. That's fine. This is the gateway. This is the range of IPs, the DNS, and the lease time. So now I have created the DHCP server for VLAN 10 and for VLAN 20. And in point number 4, they also ask us to make NAT. So we have created the VLAN, but in case now customer 1 receive an IP address which is from the VLAN 10, which is 10.10.10. something, he needs to go to the internet, then we need to do the NAT. It's the same thing that we have done in the lab of the DHCP. So let's do now the NAT. I will go to Winbox again and I will say IP firewall NAT, and then I will click here, general, anything coming from 10.10.10.0/24. So in this case, I need to make masquerade. So any packet or any IP address from this range, I will make NAT to it, so I will masquerade it. Okay, I will say apply, and then I will make copy to create a new one. Then here I will say anything coming from, in this case, 10.20.20.0, then the action is masquerade. So now in this case, when we provide IP addresses to the customers, which are customer 1 and customer 2, if they receive 10.10.10. something, or customer 2 receive 10.20.20. something, then in this case they can go to the internet because they are NATed. So point number 4, it is done. Now, our work on the main router is finished. So to make a review what we have done, we have created on Ethernet 1 the DHCP client, so there is an IP received from the ISP to here, and this router is on the internet. Then we have created 2 VLAN, VLAN 10 and VLAN 20. On VLAN 10, I have put an IP address of 10.10.10.1. Okay, so we put .1 here. And on VLAN 20, I put an IP address on the interface 10.20.20.1. VLAN 10 and VLAN 20, they were created on this interface, Ethernet 2. So VLAN 10 and VLAN 20 are both on the interface of Ethernet 2. Okay, then I created a DHCP server here, and I created also a DHCP server here. Okay, on VLAN 20 and on VLAN 10. Now, what I need to do, of course, also we made NAT, so we don't forget as well that we made NAT here and we made NAT here. So all IPs which are for VLAN 10 and for VLAN 20 will be NATed to be able to go to the internet. So we said now that the Ethernet 2 is a trunk, then in this case Ethernet 2 of this switch should be trunk, because the main router will send packets to VLAN 20, to the switch, and will send also packets to VLAN 10. Then this switch needs to accept those packets, and then he needs to send them to customer 1 and to customer 2, based on what we are going to do later on Ethernet 3 and Ethernet 4. Okay, so now let's log into the switch, and before we do that, let's see what is the point that we need to do. Point number 5, configure the switch to have trunk on Ethernet 2. So how to do that? I need first to get connected to the switch. So I will go to the wireless of the switch in order to open the Winbox to it. And then this is Winbox, and this is the switch now. So what I need to do now, first I have to create the VLANs. So the same, I will go to interface, VLANs, and then here I will say VLAN 10 is for customer 1. You can change the name here, it's not important the name, okay? What is important is the VLAN ID. So this is 10, and it should be on Ethernet 2, because if we look to the graph here, the Ethernet 2 is the Ethernet connected to the main router from the switch. So we say the VLAN should be on Ethernet 2. Okay, that's VLAN 10. And I will create also for VLAN 20. So I will say here VLAN 20 customer 2. And here 20, and it should be on the interface Ethernet 2. So as interface Ethernet 2 has 2 VLANs, then in this case this interface became a trunk. So it can accept many VLANs coming to it, which are in this case 10 and 20. So point number 5 is done. We have configured the switch to have trunk on Ethernet 2. Now, we need to assign VLAN 10 to Ethernet 3 and of the switch, and VLAN 20 to Ethernet 4 of the switch. What does it mean? So now the switch, he received VLAN 10 on VLAN 20 to Ethernet 2. But what we need to do is we have to say, okay, anything which is going to VLAN 10, then I have to let it go from my Ethernet 3. So all packets for VLAN 10, let them go from my Ethernet 3. In this case, it is customer 1. And all packets which are for VLAN 20, I want to let them go to Ethernet 4, and in this case it will go to customer 2. Okay, so this is exactly what I need to do. In this case, when I'm saying VLAN 10 on Ethernet 3 and VLAN 20 on Ethernet 4, then this port will be access. Let me take another color. Access. And this port, Ethernet 4, also will be an access port. Okay, so how to do that on MikroTik? Remember we said to have a trunk, we need to create VLANs, and we put them on the same interface like we did on Ethernet 2, we put VLAN 10 and VLAN 20, then in this case the port is trunk. To make it access, what I need to make, let's take the first case, which is for the VLAN 10. So what I need to do, I have to make a bridge. I create a bridge. Okay. And inside this bridge, I will put VLAN 10, which is coming to this interface, and I put Ethernet 3. When I create a bridge and I put Ethernet 3, which is this interface here, and the VLAN that I have already created on the switch, then in this case the interface Ethernet 3 will be access and it will be inside VLAN 10. Same if I want to do for Ethernet 4. So I create another bridge, and inside this bridge I will put VLAN 20 and I will put the interface Ethernet 4. Okay, so in this case the Ethernet 4 will be an access port and will be inside VLAN 20. Alright, so this is exactly what we have to do in order to allow the port to be an access port. Okay, so let's do that. So the question is to assign VLAN 10 to Ethernet 3 and VLAN 20 to Ethernet 4. I will go to the switch again, and what I need to do now, I have to create the first bridge. Okay, I will say bridge VLAN 10. Okay, so this bridge is going to be for VLAN 10 in order to put the interface Ethernet 3 inside VLAN 10. And I will say okay. Now, I will do here ports, and then I will click on plus, and I will say inside this bridge of VLAN 10, I want to put VLAN 10, and I want to put the second port, which is Ethernet 3, as on the picture. Okay, so in this case, Ethernet 3 is inside VLAN 10. Then I will create another bridge, and this time I will call it the bridge, and this bridge is for VLAN 20. And then inside this bridge VLAN 20, I will make ports plus, I will put VLAN 20 inside bridge VLAN 20, and I will put also interface Ethernet 4 inside the bridge of VLAN 20. Okay, so in this case the interface Ethernet 4 of this switch is now an access port and it is inside VLAN 20. Okay, so let's see what we have done now. So if we check again what we have done, that the ports here are trunk between main router and the switch, and this port is on Ethernet 4, it is access on VLAN 20, and this port is access also, Ethernet 3 is an access port and it is on VLAN 10. Then as it is on VLAN here 10 and this port is on VLAN 20, then directly this customer belongs to VLAN 10 and this customer belongs to VLAN 20. Okay, so in this case what we need to do, we have to go to the customer 1 and to the customer 2 and enable the DHCP client on their interfaces, and we will see that Ethernet 3 will receive an IP from 10.10.10. something, and Ethernet 4 of customer 2 will receive an IP from 10.20.20. something. Okay, and that's what they ask us to do in the upcoming points. Log into customer 1 router and enable the DHCP client on Ethernet 3. What is the IP address did it get? And then if the router is online, same we do for customer 2 router. So I first need to connect to the customer 1 router, and I will open now Winbox, and this is customer 1. I will say connect. I will go to IP DHCP client, and then from here I will say plus, and I will say I want it to be on Ethernet 3. Okay, that's the interface which is connected to the switch. I will leave everything as it is. I will say OK. And as you can see directly, it received an IP of 10.10.10.245, Why 10.10.10? Because that's the IP address from the DHCP server that we have created on the VLAN 10 when we were working on the main router. Okay, and now we need to check if it's online. So I will say ping 8.8.8.8, and you can see that this router now is online. So same I do on customer 2. So let's go here to customer 2 and then this winbox. We will log into customer 2. And then from here I will go to IP DHCP client and I will say plus, and this time it is Ethernet 4. And I will say OK. And look now, it received an IP but from 10.20.20. something to 50. Okay, why is 20? Because remember customer 2 is now inside the VLAN of VLAN 20. Okay, and we will see if it's connected to the internet. Then I will say ping 10.20.20.1, and that's of course to his gateway, and we can do 10 ping to 8.8.8.8, and we can see that he is able now to get access to the internet. So port number 7, it is done, and port number 8, it is done, and we have seen that both routers, they really received the IP addresses that they should receive because they are on 2 different VLANs, and everything is working as it is. Okay, now the last thing that I want to explain, and this is not the point that is on the points that we were working on. And if you remember when I was explaining in the previous lecture, I have said that when you have 2 network devices which are on separate VLANs, then they are not able to reach each other. And that's when you have only a switching network. But in our case, we have a router at the end. And I said to you, in case you have a router, then the users which are on different VLANs, they are able to reach each other. And why does it happen? Because if I go here to the graph, like for example now, customer 1, if he is on VLAN 10 and customer 2 is on VLAN 20. If you ping from customer 1 to customer 2, then he may get a ping reply. Why? Because the ping goes from customer 1 to the switch sends it to the trunk, to the router. The router makes here a routing. So it's like 2 different networks, and he sends it back to the switch, and the switch sends it to Ethernet 4 of customer 2, and then he has a reply. Okay, and that's something not good because you have 2 customers, and the whole idea that you were doing for VLAN is to separate them, and each customer is on a different network and he doesn't get connected to the other customer on our network. So we have many customers and we want all the customers to not be able to reach each other. So how can we do that? First, let me go to customer 1 and try to ping customer 2 IP address. So this is now customer 1, and if I go to the terminal and I ping 10.20.20.250, that's the IP address of customer 2 interface Ethernet 4. Okay, and you can see he has a ping reply. So that is something we really need to avoid it, because we don't want that one customer is able to reach the network of the second customer. So how to do that? Actually, it's very easy. We can log into the main router. So I will go to the main router now. And from the main router, I need to create a filter rule. Okay, so this is the main router now. I'm connected to it. And then from here, I have to go to IP firewall. And on IP firewall, I will go to filter rule and I will create a rule. I will say chain forward. That means for any packet going through the router, through the main router. So that means customer 1 is pinging to customer 2. So the traffic will come to the router of the main router and then will go to customer 2. So the packet is passing through the router. That's forward. So for everything which is passing through the main router, okay, and which has inside interface all VLAN and outside interface all VLAN, that means all VLANs, whether they are coming to the router or leaving the router, so any VLAN in any direction, and if it's forward, then the action is to drop. Okay, so I repeat it. Any traffic which is coming via the router to and going to somewhere, and if it's from any VLAN on the inside interface or the outside interface, the action is to drop it. So in this case, I'm dropping all packets which are for VLANs to not be able to see each other. Okay, and now if I go back to customer 1 and I will try to ping again customer 2. So let's try that. Now I will go to Winbox customer 1. This is customer 1, and from here I will go to the new terminal and I will say again ping 10.20.20.250. That's the IP address of customer 2 interface Ethernet 4. And as you can see here, it is request timeout. So customer 1 is not able to reach customer 2. But do you think that there will be internet connectivity? Let's try. So we ping 8.8.8.8 and no problem with the internet. So the customer 1 is having internet, but he cannot get connected to another customer on our network. And that's something we really need to make when we want to create the VLAN to our customers in our ISP. So this lab was a bit long, but it was very informative, and I showed you how you can use VLAN with the DHCP in order to provide for each customer a VLAN and then to be separated from each other. And I hope that you enjoyed this lab, and I will see you in the upcoming lecture. Hi there, this is Mar Haddad here again. In this lecture, I have to show you how you can create VLANs using the switch chip, which a lot of MikroTik routers, they have it, which is inside the router itself. So as you can see here, we have 12 points to do. But before I start doing those points, let me explain to you what is the lab scenario, and then we will come back to the points and start doing that. So as you can see, the lab scenario is the same as we have done in the previous lab, but the only difference is that I'm going to use the switch chip, which is inside the MikroTik router. So what is the switch chip? It is a chip which makes for you switching, so layer 2 connectivity, and then what you can do that in this case, as you have a switch chip, then the frame will not go anymore to the CPU, but it will go via the switch chip directly, and that makes your layer 2 connectivity goes much faster. So there is a way that you can create VLAN if you use switch chip, and in this lab I'm going to show you how you can do that. In the previous lab it was something different, but the same concept is the same. So what we have here is that we have the router over here and we have a switch over here, and this router is going to provide internet for this customer and for this customer on two different VLANs, one on VLAN 10 and another on VLAN 20. So the same scenario that we have seen in the previous lab is going to happen on this lab. But the only thing is that creating the VLANs on the switch over here is going to be different, because we are going to use switch chip, which is on the MikroTik router, to make the VLAN. And that feature is possible since the version 6.41. So if you have a router which is on the version below 6.41, then you cannot do what I'm going to do in this lab. But in case you have a router with a newer version, so 6.41 plus, then in this case you can do the configuration as I'm doing in this lab. Now if you have an older version, so I'll always recommend that you make an upgrade for your RouterOS, and then you have the newest version and you do the configuration that I'm going to show you in this lab. So this is what we are going to do in this lab. Let's go now back to the points and start doing that. Point number 1, enable the HTTP client on Ethernet 1 of the main router and check if it's connected to the internet. Okay, let me just put the picture here, and let's go directly. We have to go to the main router and enable the internet. So we are going to do the first, actually 1, 2, 3, 4 points are the same as we have done in the previous lab. So I will go a bit fast on those points because you already know how to make it. So let's go to the main router. This is the main router. I will go to IP DHCP client, and then from here I will say I want to enable the HTTP client on Ethernet 1, and then I will say okay, we'll leave the default route and DNS, and we will see in a moment, yes, the router is now connected to the internet. If you want, we can check. We make a ping to google.com, so we can also check that the DNS is working, and here we go. We see that everything is fine on router 1 as for the internet. Point number 1 is done. Point number 2, now we need to create the VLANs, VLAN 10 for customer 1 and VLAN 20 for customer 2 on the main router. So this router is the distributor router, which is distributing for me the internet. So the same steps that we have done in the previous lab is going to happen on this lab also. So let's do that. We go here to the interfaces, and we create the first VLAN. We name it VLAN 10, and then the VLAN ID is 10. It's gonna be on the Ethernet 2. So Ethernet 2 is gonna be the trunk port which is on this router. Okay, so this is done over here. I'll make apply. I'll make copy to make another one for VLAN 20. And VLAN ID is 20, also on the Ethernet 2, and then I'll say okay. So now we can see that we have the two VLANs that are on Ethernet 2. That makes the Ethernet 2 a trunk port. Port number 2 is done. Port number 3, now we need to put the IP addresses because we need to create the DHCP servers on those VLANs. So the IP addresses are also the same as we have done in the previous lab. So we go to IP address, and from here I will put 10.10.10.1/24, and this is gonna be on VLAN 10. Then apply, I'll make a copy, and then I will make another one which is 10.20.20.1, which is going to be on VLAN 20. And remember, we need the IPs to be able to create the DHCP server. So those IPs are created here for VLAN 10 and VLAN 20. Port number 3 is done. Port number 4, create a DHCP server on VLAN 10 and on VLAN 20, another DHCP server, and make NAT. All right, so I will go here for the IP DHCP server, and then from here we go DHCP setup. And first I want to make on VLAN 10, I create a DHCP server here, so all is okay, the DNS, and then next, and then this is done. Now we create another one from the VLAN 20 to be the gateway, so 10.20.20.0, that's fine. This is the gateway here, fine. And yes, so this is done here, the DHCP server. And to make the NAT, so it's just easy, we can just say IP firewall NAT, and then we go for here. So we can just do source NAT, action is masquerade. So let's do it this way. So now the main router is being configured correctly with all configuration that we need. Port number 4 is done. Port number 5. Now we need to go to this switch and we have to start doing some work. So go to the switch and check if it has a switch chip. So I'll move the cable from the main router and I will put it on the switch. And we'll go to Winbox. And first we need to check if this router has a switch chip, because some routers, they don't have it. So I will go to the switch and I'll connect to it. So we are now inside the switch. To know if you have a switch chip on your MikroTik router, you can see it over here. You can see this one, switch. So once you see that there is a switch over here, then you know that there is a switch chip. Another way to know is to go to the terminal, and you can say here interface Ethernet switch, and then you can say print, for example. And also it will show you that you have a switch over here. It is type RouterOS 8227. So you do have a switch chip on the MikroTik router. Port number 5 is done. Port number 6, create a bridge port and put inside of it Ethernet 2, Ethernet 3 and Ethernet 4. Ensure that hardware offload is checked. Before I do this point, just remember that when you check the switch chip, there is also on wiki here. So you can see on the wiki, which is on MikroTik, you can see that if this type of switch chip can have VLANs. And in my case, if we go back to the router or the switch, and we have seen that the switch chip is called RouterOS 8227. So if we go to the wiki here, and we check RouterOS 8227, so over here, you see what this can do, this switch chip. And here we can see that we can have up to 4096 entries for VLAN. That means it is able to create VLANs on this switch chip, okay? So if you want, I will keep this link for you. I will just put it, you can download it. I'll put it on the notepad, then you can download the notepad to see the link, which is on wiki website. Okay, so this will show you here all the switch chip that are available on the MikroTik router, and you check on your MikroTik router if this switch chip can do VLAN, if not, if yes or not, because some of them, for example, you see this one like ICP Plus and MT721, 7621, so those they cannot do VLANs. All right, so this one we can do VLAN, very good. So now what they are saying to us is to create on the switch that we have a bridge, and then we put inside of it Ethernet 2, 3, and 4. So we create a bridge because the bridge is just to make the router as a switch, and we have to put inside of it Ethernet 2, 3, and 4 because those are, Ethernet 2 is going to be the trunk, 3 and 4 are going to be access. And then we have to make hardware offload enabled, because if you make hardware offload enabled, then the frame will go to the switch chip and to the other side. So it doesn't go to the CPU anymore, okay, which makes things to go much faster. So let's do that. We go to the router and we create a bridge. And I'll just create a normal bridge. We name it bridge 1. And then inside of this bridge, I'll put Ethernet 2. And remember, hardware offload should be checked here. And then I'll say apply, then copy, Ethernet 3, and then apply, then copy, Ethernet 4, then we make apply, and then we have now a bridge port having all those 3 ports, so they are now working as a switch, and now we need to work on VLANs. Now, if you go to the switch over here, you can see that the ports which are on the switch is showing up over here. There are Ethernet 1, 2, 3, and 4. So these are the ports that you can make them as a switch, and then you can use the switch chip to be able to forward the frame from one port to another. Okay, and you can see that, for example, the WLAN is not showing up. So that means WLAN is not part of the switch. So in this case, if you want to use WLAN, then you need to send the frame to the CPU and not anymore to the switch chip. Port number 6 is done. So we have created the bridge, we put inside the bridge the ports, and now we have to start working on the VLANs. So how to do the VLANs on this? Actually, I think I'm the first one making this video showing up how you can create the VLANs using the switch chip. And that's something that I'm glad that I'll be the first one explaining about this feature, because it's somehow a new feature on MikroTik. Now go to the switch and then VLAN and create VLAN 10 for Ethernet 2 and 3 and VLAN 20 for Ethernet 2 and 4. So what we need now to do is to go here to the router or to the switch, and from here we go to this switch over here. Okay, so we finished from the bridge. Now we need to work on the switch over here. All right, so they are saying, okay, now you have to go to the VLAN and you have to make the VLAN. So you have to say which port is trunk and which port is access. So we create the first VLAN, and this VLAN I will say, okay, I want it to be on the switch. The VLAN ID is 10. Remember, we have 10 and 20. So 10 is going to be for Ethernet 2 because it is trunk port. So trunk port will carry the tag which is VLAN 10, and also Ethernet 3 because Ethernet 3 is going to be the one which is going to connect to the customer on VLAN 10. Okay, so that's what it's saying here. VLAN 10, Ethernet 2, and 3. Okay, and then I will say, okay. Now I will create another one, and now I will say VLAN 20 is going to be for Ethernet 2 because also it's a trunk port, but also for Ethernet 4 because it's going to be the access port, and it will have the VLAN 20 on it. And then I will say, okay, so you understand what I'm doing now. I'm just saying that Ethernet 2 is the trunk port, can take the VLAN 10 and 20, and Ethernet 3 is an access port, so it is for VLAN 10, and Ethernet 4 is an access port, it is for VLAN 20. Okay, port number 7 is done. Port number 8, go to the switch, then port, and on Ethernet 2 make VLAN mode secure and VLAN header add if missing. So what we need now to do, we have to say that the ports, which is Ethernet 2, is the trunk, and the ports which are Ethernet 3 and Ethernet 4, they are access. So how to do that? We have to go again here to the switch, but now we finish from the VLANs and we go to the port. On the port over here, we can go to Ethernet 2 first. And Ethernet 2, the VLAN mode, always we have to put it here secure. Okay, so we say secure. But then on the VLAN header, we have to say add if missing. So if there is no tag, then add it because that's a trunk port. And that's what we need to do on Ethernet 2. And in this way, you are saying that Ethernet 2 is a trunk port. So this means that Ethernet 2 is a trunk port. You put VLAN mode secure, VLAN header, add if missing, and that's it. So this is done for Ethernet 2. Port number 8 is done. Port number 9, we also have to go to the switch, then to the port, and then we go to Ethernet 3, make VLAN mode secure, VLAN header always strip, and default VLAN ID is 10. So we have now to say that Ethernet 3 is an access port, okay? So how to do that? We go to VLAN 3, and remember always VLAN mode should be always secure. And VLAN header, we have to say always strip, okay? Because remember when the VLAN or the package which are for the VLAN 10 are coming to the port Ethernet 3, then in this case Ethernet 3 would take out the tag and then it will send it to customer 1, and that's what means always strip. And the default VLAN here, it's VLAN 10, right? Because that's on Ethernet 3. Ethernet 3 is VLAN 10. And please look to the picture so you remember and you know what I'm doing. So this is done for Ethernet 3, and also we have to do it on Ethernet 4. But in this case, on Ethernet 4, we have to remember that it is going to be for VLAN 20. So let's do it. I just want to make it a bit small because it's too big. So we have to do here to say VLAN mode, it is secure. VLAN header is always strip, and default VLAN is 20. And then I will say, okay. So now everything looks fine for me. Port number 9 is done, and port number 10 also is done. We have done the 2 ports together. Now we need to make the test. So this is how you can create the VLANs using the switch chip. And you can see it's different than the method that I have showed you in the previous lab. Now we need to make a test. So I'm gonna put my computer to Ethernet 3 of the switch and check if it receives an IP of 10.10.10. something, because it is on VLAN 10. Then I will put it on Ethernet 4, and then it should receive an IP of 10.20.20. something, because that's on VLAN 20. Okay, and then we will see if in both cases the PC is going to be connected to the internet. For now, if you want, I can just show you that this is my PC. If I ping 8.8.8.8, I don't have internet because the PC is not connected to the internet. Okay, so let's do that. I will take the cable of my PC and I will put it first on Ethernet 3. So Ethernet 3 is customer 1. That means it needs to get an IP of 10.10.10. something. Okay, so of course we got disconnected from the Winbox because I just moved the cable. Now we go to the network and settings for the Windows, and here we have to enable the DHCP client on the PC. We go to the adapter, and from here I will go to, this is the only interface I have enabled, so I will go from here to properties, and from here to TCP IP. I will say obtain IP address automatically, but also DNS, and then I will say okay and okay. And we see that it has received something. And to justify, I will say ipconfig/all. And we can see that indeed it has received an IP of 10.10.10.254. Why? Because it is connected to Ethernet 3, which is on VLAN 10, which is connected back to the main router and giving an IP from 10.10.10. something from the DHCP server. And if I want to make now a ping to 8.8.8.8, indeed I'm connected to the internet. Okay, now this is everything is fine on Ethernet 3. Let's try now on Ethernet 4. So I will move the cable now from Ethernet 3 from the switch, and I put it on Ethernet 4. Okay, so here we were having 10.10.10.254. Now I will check ipconfig/all, and we should receive an IP address actually in a moment. Yes, you see now it has received an IP address, but this time it's 10.20.20.253. So this is coming from VLAN 20, which is on the main router, because we have made the port on Ethernet 4 of the switch to be on VLAN 20. And now if I make ping again to 8.8.8.8, we see that we are connected to the internet. So we can see that the configuration that I have done is working perfectly, and this is how you can create VLANs in the new way if you want to use the switch chip. Port number 11 and port number 12, they are done. And with those last 2 points, I have showed you how you can create VLANs using the switch chip. So you can see it is very nice and efficient way, because everything now is passing through the switch chip without going via the CPU of the router, and this makes your life much easier. Especially you can see that it's gonna be much faster if you use this method. So this is what I wanted to show you in this lab. I'm again glad that this lab, I'm the first one who is showing that clearly on a video how to be configured, and I hope that it was really informative for you, and I will see you in the upcoming lab. Hi there, this is Haddad here again. In this lecture, I have to show you how you can configure VLANs in case you don't have a switch chip. Okay, or in case, for example, you are using some interfaces which is not belonging from the switch chip. For example, the wireless. If you have wireless, the wireless interfaces are not part of the switch chip. So how can you create the VLANs for these type of interfaces? So as you can see here, we have 8 points to do. But before I start doing these points, let me go back to the lab scenario to explain to you what we need to do in this lab. Then we will come back and start doing those points. So we are still on the same lab scenario. Actually, on the main router, I didn't touch it. So the whole configuration that we had on the main router, I just left it as it is. So we have VLAN 10, VLAN 20, and they are all on the interface Ethernet 2. So the Ethernet 2 is the trunk over here, and we have the DHCP server. So I didn't do anything on that part. What I'm going to work on is on this router, the router which is going to be the switch. So we have to imagine that we have Ethernet 3 and Ethernet 4 are not part of the switch chip. So what we need to do in this lab is just to uncheck the hardware offload. Then in this case, they will not work from the switch chip anymore. Okay, so the traffic has to go via the CPU. So in this case, I'm gonna show you how you can configure the VLAN on this switch in order to allow at the end that this customer to get IPs from 10.10.10. something, because it's going to be on VLAN 10, and this customer here will get an IP of 10.20.20. something because it is on VLAN 20. So again, this is just to show you that in case you have a router and it doesn't have a switch chip, so also there is a way that you can configure VLANs from the bridge itself, and then this will work perfectly without any issue. So now we know what is the idea of the lab. Let's go back to the points and start doing them. Point number 1, create a bridge port and put inside of it Ethernet 2, 3, and 4. And we need to ensure that hardware offload is unchecked, because we have to think now that we have a router without switch chip. So I don't have now a router without a switch chip. So what I'm going to do is just to uncheck the hardware offload. That means it is not going to use the switch chip anymore. Okay, so let's go to the router directly. And first I put the picture here and we go to the router. So the first thing we need to do on this switch, again, the main router is already configured. We don't touch it. Okay. So we go to the bridge and I will create a bridge. And from here, after creating the bridge, I put inside of it the ports, which are Ethernet 2, and then hardware offload unchecked. Then I will say apply, copy, and then Ethernet 3, hardware offload is unchecked, and apply, then copy, and then finally Ethernet 4, hardware offload unchecked, and then that's it. So now I have the 3 ports inside the bridge. Port number 1 is done. Port number 2. Now we need to start configuring the VLANs in this case. So you will see it's similar to what we have done when we were using the switch chip, but there are some difference, of course. Okay, so let's see what we have to do. In the bridge, go to the port Ethernet 3, then VLAN, and then put VLAN ID 10. So we have to go here, and then from this one, we have to go to the ports over here, and then to Ethernet 3. And then here we have VLAN, you see it? So we go to VLAN, and then we say that Ethernet 3 is on VLAN 10. So that's what we need to do, okay? And then I will say, okay. Then also we have to do the same for Ethernet 4. And here we have to say that Ethernet 4 is on VLAN 20, okay? And that's it. Port number 2 is done. Port number 3 also is done. Now port number 4. from the bridge, go to VLAN and create a new bridge VLAN with VLAN ID 10, tagged Ethernet 2 and untagged Ethernet 3. So what we are going to do now is just we have to say to the router, to the switch, we have to say, okay, then now what I want you to do is to make tagged for Ethernet 2 means it is a trunk, and then untagged it's Ethernet 3 because it's an access port. Same we do the second time, which is for VLAN 20. I have to say that the tagged is Ethernet 2 because it's a trunk, it has to tag, and then the untagged is the Ethernet 4 because it's an access port. And all this we have to go to do it from the bridge and then from the VLAN. Okay, so how to do that? We go from here. So we finish from this part. So at this part, what we have done, we just put the ports inside. We have said that Ethernet 4 is on VLAN 20 and Ethernet 3 is on VLAN 10. Now we need to go from here to the VLAN. And now we have to create a bridge VLAN. And from here we have to say on bridge 1, there is a VLAN that is VLAN 10. And the one which is tagged, so the interface which is tagged means the trunk is the Ethernet 2. And the one which is untagged for VLAN 10, which one is it? It is Ethernet 3, okay? So this is the access port which is on VLAN 10. All right, so that's what I'm saying over here. And then I'll say, okay, apply, and that's it. So now I will do another one for the VLAN 20. On VLAN 20, the tagged is Ethernet 2 because it is the trunk port, and untagged it is Ethernet 4 because it is the access port. Okay, so untagged means the tag will be removed and then the packet will go, or the frame will go to the PC or to the customer, and that's gonna happen on Ethernet 4. And then I will say, okay, so this is what I need to do from this side. Point number 4 is done, and then point number 5 also is done. We have done the 2 points, and then the last point we need to do is to go to the bridge 1 and then VLAN and enable VLAN filtering. So at this moment, what we have done is very good, but it doesn't work unless you enable VLAN filtering on the bridge. Okay, so we go to the router again, and now from the bridge here, we go to bridge 1, and on bridge 1 we have the VLAN, and that's where you have to check VLAN filtering. Okay, so you just check VLAN filtering. That means to allow the processing of the VLAN to work, and then I will say okay. All right, so just as a review what we have done, we have created a bridge. We have put inside the bridge the 3 ports, Ethernet 2, Ethernet 3, Ethernet 4. Then I went to, of course, here we didn't check the hardware offload, and you can see the H here on the flag, it doesn't show up. Then on Ethernet 3 and Ethernet 4, I go inside of it and I put for them the VLAN ID. So Ethernet 4 is 20 and Ethernet 3 is 10. Okay, that's what I have done here. Then afterward, I have here created on the VLAN a new one. So new VLAN bridge VLAN, and then I will say that for the VLAN 10, the tagged is the Ethernet 2 and untagged is Ethernet 3. That's for VLAN 10. The trunk is Ethernet 2, the access is Ethernet 3. Then also I have made another one here, and I said for VLAN 20, the tagged is Ethernet 2 because that's the trunk port, and the untagged is Ethernet 4. Then finally, I have here moved to the bridge on bridge 1, and to allow the VLAN to work, I only have to go to VLAN and say VLAN filtering enable. I just check it and that's it. So this is the whole configuration. In case you don't have a switch chip on your router, this is the whole configuration that you need to do. Now we need to do the experiment to see if it's gonna work. Point number 6 is done. So we have enabled the VLAN filtering. Now we need to connect the PC to Ethernet 3. Remember, Ethernet 3 is VLAN 10. That means the PC has to get an IP of 10.10.10. something and to be able to go to the internet. Let's do that. I'll move the cable of my PC and I put it on Ethernet 3. So the cable now is on Ethernet 3. Then I will go to the settings of the network card to enable the DHCP client. Okay, so before I do that, I just want to show you that at this moment, if I open the command prompt, I don't have internet. So if I make, for example, now ping 8.8.8.8, so we don't have internet. Let's close this one. Now we go to the interface, and from here I will just say obtain IP address and DNS automatically, and then OK. And let's have a look. It looks like we have received an IP. So let's have a look now. If I say ipconfig, and here we go. You can see I received an IP of 10.10.10.254 because it is on VLAN 10, remember? So now if I ping 8.8.8.8, it wasn't successful. And yes, now I can go to the internet. All right, let's move the cable now and put it on Ethernet 4. So now the cable is connected to Ethernet 4 and it is identifying now and it is looking that it is connected. If I make ipconfig, look now, the IP is 10.20.20. something. So that's because on a VLAN 20. Okay, and if I make ping to 8.8.8.8, and here we go, it is working. So you can see how nice is MikroTik when it comes to the VLANs, and those features, there are new features again. So not a lot of people are using them, but of course, I'm sure that now with my videos, you are able to configure VLANs without any problem. Point number 7 is done and point number 8 is done. And with those points, I have also showed you how you can create VLANs. And in case you don't have a switch chip, so how you can create it from the bridge itself and to make it work for you. So I hope that this lecture was informative for you, and I will see you in the upcoming lecture. Hi there, this is Mar Haddad here again. In this lecture, I have to speak about Q-in-Q implementation, which means to create a VLAN inside another VLAN. So I'm gonna show you in which cases you may have to configure Q-in-Q, and then I will do this lab, which is 8 points. So let's go now first and explain to you in which cases you may have to configure Q-in-Q. Then we come back to the points and start doing them. So imagine you have this scenario. You are an ISP. So this over here, the switches are part of the ISP. So this is here ISP. Okay. And then you have here one customer. So customer 1, and here you have customer 2, and they are connected to your ISP. Okay. Now, in case, for example, the customer 1 has bought the company of customer 2, so then in this case, those two companies are for one company. Now, what they want is to merge the networks between which is over here, this network and this network. They want to merge it together. So what you can do over here, you can create Q-in-Q, because the customer will come and say, well, I want all my traffic to go from VLAN 20, okay? And also over here, he will say that the VLAN 20 is the VLAN that I'm gonna use. But inside your network, you are using, for example, VLAN 10. So on the switches here, which are the core switches, for example, then you are using VLAN 10. Okay, so in this case, how come you can carry the VLAN 20 to pass from inside your network via VLAN 10? So what you can do, as you have here VLAN 10 on your network, then you create inside this VLAN another VLAN, which is VLAN 20. Okay, so VLAN 20 will come inside the VLAN 10. So the traffic which is coming from this side, which is on VLAN 20 to here, it can pass from here to go from here and vice versa. Okay, so this is the Q-in-Q. It's just here in this case, the two routers, which are router 1 and router 2, will become like connected to LAN. Okay, they are on layer 2, and that's where you can use the Q-in-Q. You just have, in case you have on your network, you are using VLAN 10, for example, then you create VLAN 20 under the VLAN 10, and then the traffic can carry from one side to another. So this is the whole idea of the Q-in-Q. Normally, Q-in-Q is used on Metro Ethernet. So ISPs, in this case, for example, that this is one example that I'm showing you, that when they want, for example, to connect two networks to each other, and those customers, they say we are going to use VLAN 20, then in this case they can just create a VLAN under the VLAN that they have to allow the traffic to go to the other side. So this is the whole idea of Q-in-Q. In case it's not very clear for you, I will do a lab now and I will explain to you step by step how you can configure it on the MikroTik router, and at the end we are going to make an experiment and check if it's working. Then I'm sure that by the end of the lab, you will understand it much better. Let's go now back to the points and start doing them. Point number 1, create VLAN 20 on router 1 and put it under Ethernet 2, assign it an IP of 192.168.12.1. Let me put the picture here and let me explain to you what we are going to do now. So now the customer has said to us, okay, I'm gonna send you VLAN 20. So my traffic will be on VLAN 20 on both routers. So what I'm going to do now, just to create a VLAN 20 on router 1 and later on router 2 and put it under Ethernet 2 on this side, and on this side I put it under Ethernet 4, just to say that that's VLAN 20 configured from the router side. Okay, let's do that. So we go first to router 1, and from router 1 I will go to interfaces, and from here I will create a VLAN 20, and from here I put VLAN ID 20, and it is going to be under Ethernet 2. Okay, that's the outside interface going from router 1, and that's it. So now you can see it over here, and now we have to put an IP address on it. I'll just go and say IP address, and I will create an IP which is 192.168.12.1/24, and it is going to be under VLAN 20. So this is all you need to do on the router 1. Point number 1 is done. Point number 2, we have also to create the VLAN 20, because that's again the VLAN that the customer has told us as an ISP that he wants to send his traffic from. So on router 1 we have done it. We have to do it now on router 2, and we have to put it under, actually it should be here Ethernet 4 and not Ethernet 2, because Ethernet 4 is the one which is connecting to the switch of the ISP. So let's do that. We go to router 2. That is router 2 now, and from here we create VLAN, and the VLAN we have to name it VLAN 20, and it has VLAN ID 20, and it is under Ethernet 4. Now we just put an IP address on it, IP address, and it's gonna be 192.168.12.2/24. It's the same range as the one we made it on router 1. And we put it under VLAN 20. So this is also done on router 2. Point number 2 is done. Point number 3, now we need to start working on the switches. So we have to make Ethernet 3 interfaces on switch 1 and switch 2 as trunk port to carry VLAN 10. So the idea is that, okay, now we are going to make on this switch those interfaces to be trunk, and they have to carry only VLAN 10. Okay, that's what we use inside our ISP network, that the traffic will be carrying only VLAN 10. Okay, and later you will see that we will put the VLAN 20 under the VLAN 10 to be able to carry from one switch to another. So now let's do that on switch 1 and switch 2. Create the VLAN 10 and put them under the interface Ethernet 3. We go to switch 1. And from here I have to go to the interface. I create VLAN, I name it VLAN 10, it has a VLAN ID 10, and it is under Ethernet 3. So this is done, you can see it over here. And we do also for switch 2 on interfaces. I create VLAN, that is the name, and the ID is VLAN 10, and also it is under Ethernet 3, you can see on the picture, because it is the one directly connected to switch 1. And then I will say OK. So you can see that VLAN 10 is under Ethernet 3 on this switch, and also on the second switch also it's under Ethernet 3. Point number 3 is done. Point number 4, create VLAN 20 under the VLAN 10. So at this moment, if we look back here, so we have already configured this. We have router 1, router 2 are on VLAN 20, so Ethernet 4 and Ethernet 2. And now here we have VLAN 10. But I want, in case it comes to here and it is VLAN 20, it has to go via the trunk over here. So what I'm going to do, I just have to create a VLAN 20, but I put it under the VLAN 10. So that's what is Q in Q. Q means 802.1Q. That's the encapsulation. That's why they call it Q in Q. So we create the VLAN 20 under the VLAN 10, so it can go to the other side. Okay, because we are using, on our network, we are using only VLAN 10. So we have to put a tag which is VLAN 20 to go under the VLAN 10 to be able to go to the other side. Okay, let's do that. We go to the switch. This is switch 1. And now I will create another VLAN. And I will say, okay, VLAN 20, which has a VLAN ID 20, then put it under VLAN 10. And that's it. You can see now VLAN 20 is under VLAN 10. And also we do it on the other side, which is switch 2. I will say VLAN 20, that is the name, and it has a VLAN ID VLAN 20. We put it under VLAN 10. And that's it. So you can see VLAN 20 is under now VLAN 10. Point number 4 is done. Point number 5, we have to make Ethernet 2 of switch 1 and Ethernet 4 of switch 2 as an access port on VLAN 20. So what is the idea here? If we go back to the picture, so the idea is that we have to say that this interface here, the Ethernet 2, and this interface here, which is Ethernet 4, they are on VLAN 20, correct? And also here on VLAN 20. So that means that for any incoming or outgoing traffic, there are VLAN 20. Also here, incoming and outgoing, because here we put it on the router VLAN 20, on the switch we put it VLAN 20, and also here. So that's why in this case the traffic will work between the switches and the routers, because we put them on VLAN 20. So we make now the ports Ethernet 2 and Ethernet 4 of the switches access ports, and we put them on VLAN 20. So how to do that? That's something we know already because we have seen it in the previous lab. So we go to the switch 1. And now on the switch 1, what I need to do is to create a bridge. So we just create a bridge, and inside this bridge I put the port. First I say VLAN 20, and I will put also Ethernet 2, which is the one connected to router 1. So in this case I'm saying that Ethernet 2 is an access port on VLAN 20, and I will do the same on switch 1, but now it is going to be on Ethernet 4. So we create a bridge, and then after I create the bridge, I create the port, which is VLAN 20 and Ethernet 4. Okay, so in this case, I'm saying that Ethernet 4 on the switch, it is an access port on VLAN 20. Port number 5 is done. And now we have finished the configuration. We have to see if router 1 can see the router 2 neighborship. But before I do that, let me just do a review what we have done. So at the beginning, I put Ethernet 2 on the router 1 on VLAN 20. So this is on VLAN 20 and also here VLAN 20. Okay. Then I created VLAN 10 here and 10, and that's to be like trunk here. So the trunk between those switches is VLAN 10. Then I said that under VLAN 10 I need to create VLAN 20 to be able to the traffic to go from the router 1 to router 2, because we are using only VLAN 10 inside our ISP network. Okay, so that's what we call it Q in Q. We created a VLAN inside a VLAN. Then after that I have made this port here and this port here as access port, and I put them on VLAN 20. Okay, because they are connected to the other routers and on VLAN 20. Okay, so that's what I have done. Of course, I have put IP addresses here and here, because at the end I want to ping from router 1 to router 2. I created them on the VLAN 20. So let's now check if router 1 can see router 2 as neighbor. So we go to router 1. And from here you can go to IP, and you can go to neighbors, and you can see indeed he can see router 2 on his table, you see. And if you want, we can just ping it and say from here 192.168.12.2, and here we go. You can see now the router can see router 1 can see router 2, and if you want also we can check here. We can pick the MAC address, because you see it is layer 2 now, because the VLAN works on layer 2, and also it's able to ping the MAC address. So yeah, the Q in Q is working without any problem for us. Point number 6 is done. Point number 7 is done. Now the last point is to just make torch so we can see the VLANs, what's happening. So what I'm gonna do now, I just go to, for example, let's go to router 1. This is router 1. And from router 1, I will create a ping. Okay. Just let me make it small a little bit so we can see what's happening. So I'll make a ping from here to 192.168.12.2. So the ping is ongoing and everything is fine. We have a reply and no problem. Now let's do some torch. So I go to router 1. Now I'm here, and from here I do torch to see which VLAN it is passing via Ethernet 2. Ethernet 2 is the one connected to switch 1. So I'll go to Ethernet 2, and here I will say, let me see the VLAN ID. And then I will say start. And here we go. You can see directly it's saying to me that the ping is going and it has a tag of VLAN 20. Very good. And that's what we have done, that on the Ethernet 2, it needs to be on VLAN 20. So this is done on router 1. Let's continue the chain to go to the switch 1. Now switch 1. And from here, the ping is still ongoing, and I will go now and check on torch. If we go to torch and we go to Ethernet 2 on switch 1, which is connected to the router 1, and also I want to see the VLAN ID. Let's have a look. And here we go. It is VLAN 20. Excellent. So that's also what we need to have. Now let's have a look on Ethernet 3. Ethernet 3, we said it is VLAN 10 and it has under it VLAN 20. And then I will say start, and here we go. You see it's VLAN 10. Actually the torch will not show you VLAN 10 and 20 because 20 is under VLAN 10. So far so good. Everything up to now is showing fine, but you can see that even though that Ethernet 3 is here showing VLAN 10, but VLAN 20 is still passing inside VLAN 10 because it is Q in Q. It is a VLAN under the VLAN. So we go to switch 2 now. On switch 2 we have to check on the, if we go to torch, and we check Ethernet 3. So let's have a look. Ethernet 3 is the one connected to the switch 1. And let's have a look. Indeed, it is VLAN 10. So far so good. And now we check on Ethernet 4, which is connected to the router 2. It should be VLAN 20 in this case. Let's have a look. Yes, VLAN 20. And finally, router 2 on Ethernet 4. So we make torch, router 2 and Ethernet 4, VLAN, should be VLAN 20. Here we go. So we have looked for the whole chain, starting from router 1 where the ping is passing to router 2, and we have checked, and you can see that the packets are tagged correctly and the queue in queue is working perfectly to allow VLAN 20 to pass to the other router inside VLAN 10, which is on my ISP. Point number 8 is done, and with this point I have explained to you what is the queue in queue and where you can use it, and I have showed you with the lab how to configure it, and we have seen that at the end that it is working perfectly without any issue. And this topic, I can say that if you search on it on the internet to see how to create queue in queue on MikroTik, you cannot find a lot of resources. So I'm very happy that with this video you can have it like a resource for you. So in case you want to create queue in queue in your network, you can come back to this video and you can refer to the configuration that I have done and you can apply it on your network. So this is what I wanted to show you in this lecture. I hope that it was informative for you, and till next time.
Hi there, this is Mar Haddad here again. In this section I have to speak about how to configure VLANs on the switches which are from the model of the CRS, the Cloud Router Switches. So configuring VLANs on the CRS is different than configuring VLANs that we have seen on the router board. Even though that on the CRS, which are series 100, 200, and also 300, you use the RouterOS, but on the 300, we can also use the SwitchOS actually. But on using RouterOS doesn't mean that the configuration of the VLANs to create VLANs and make the trunk port and the access port is the same. So for this reason, I have bought this switch, which is a cloud router switch, and it is CRS 109. If you want, I can show it to you on the camera. So you can see this is a cloud router switch, and it is CRS 109. So it has many ports that I don't need more than that for the lab. And actually, I don't need to use the switch at home because I already have a lot of router boards. But I just bought this one to be able to do for you the labs, to show you how you can create VLANs on CRS. And if you want also to follow this course and you want to also make VLANs on CRS, so you need to buy this equipment. This is the cheapest equipment that I could find on MikroTik, the CRS 109. So it is from the 100 series. Of course, you can buy the 200, but then you have to pay much more. So this is what I need. I don't need more than that. And I'm going to show you using this product how you can create the VLANs. And then we'll do the same lab that we have done in the previous section. We have to connect this one to the main router and to distribute VLANs, and then to see if the other side, which in my case will be my PC, to be able to be connected to the internet via VLAN 10 and VLAN 20. So this is what I'm going to do in this section. If you are ready, let's go directly and start creating VLANs on the MikroTik CRS. Hi there, this is Mar Haddad here again. In this lecture, I have to show you how you can create the VLANs using the CRS 109. That's the product that I have bought just to be able to do the lab for you. So as you can see here, we have 9 points to do. But before I start doing those points, I just would like to go to the lab scenario, and then I will explain for you on the lab what we need to do. So we are still on the same lab scenario. Actually, the main router over here, the configuration which we have done it already when we were working on the router board, is still there. So it is connected to the internet, and it has the VLANs, VLAN 10, VLAN 20. It has the IP on the VLANs, the DHCP, and the NAT. So everything is configured the same as on the main router. So I'm not going to do anything for now on the main router. In the upcoming lab, of course, I need to do some work, which is to do the VLAN management. But for this lab on the main router, we're not going to do anything. So what I have done, I just removed the router board and I put in place here the CRS that I have, which is CRS series 100. I put it here. And then I connect here Ethernet 2, and then here Ethernet 3 and Ethernet 4. And now we need to create the VLANs on the switch. So we need to do this port as a trunk, those 2 ports as access, put these ports on the VLAN, this one VLAN 10 and this one VLAN 20. And this is to be a trunk port on Ethernet 2. And at the end, we have to see that if I connect my PC to Ethernet 3, it will receive an IP of 10.10.10. something. And if I connect my PC to Ethernet 4, it should receive an IP of 10.20.20. something. Okay, so this is the main idea of this lab. Using CRS, configuration of the VLAN is different than configuring VLANs on the router board as we have seen. So you will see that the configuration is totally different. So that's why it's important that I show you this, because you may have a switch of CRS and you may need to configure the VLANs. So by this video, you will see how you can configure the VLANs on the CRS. And just to mention that the CRS has the RouterOS also. So even though it's a switch, but it used the RouterOS. So we will see that we connect normally on the Winbox, and we do the configuration as if this is a router board. So this is what I'm going to do in this lab. Let's go back now to the points and start doing them. Point number 1, the main router still have the old configuration. So I'll put here the picture, and the main router, I don't need to connect to it now, but it has the old configuration, so I didn't do any change on it. So this point is done. Now, point number 2, we have to start working on the CRS switch. Connect to the CRS via Winbox and put Ethernet 2, Ethernet 3, and Ethernet 4 in the bridge port. So actually, because we are using RouterOS, we need to make a bridging, because then the ports, which are Ethernet 2, 3, and 4, they have the hardware offload, and then they can work as a switch. So we need just to put those interfaces on a bridge. So let's go to Winbox. So this is Winbox open, and from here you can see this is CRS 109. It has a 8 gigabit Ethernet port and 1 fiber port, so that's more than enough to be able to do the lab. So I will say okay, connect. So this is the switch. You can see now it has no any configuration. So if I say here export, you can see that it has no any configuration on it. I have reset it with no configuration. I just changed the name. I put it switch, so we know that this is the switch we are working on. Now we need to go to the bridge. We create a bridge,
and we put inside of it Ethernet 2, and we put inside of it also Ethernet 3, and we put also Ethernet 4. Actually, if you are going to use all the ports to be like switch, for example, then you can select them all. But in my case, I'm just working on Ethernet 2, 3, and 4, so I just put those inside the switch. And remember here, the hardware offload should be checked. And then I will say, okay. So now the 3 ports that I need to use them, Ethernet 2 to be the trunk, Ethernet 3 to be access port on VLAN 10, and Ethernet 4 to be access port on VLAN 20. Those what I need to put them inside the bridge. Port number 2 is done. Port number 3. Now we need to go to this switch, then VLAN, and we have to put Ethernet 2 and Ethernet 3 under VLAN 10 because Ethernet 3 is an access port. It should be on VLAN 10, and Ethernet 2 because it's a trunk port, then it can also carry the VLAN 10 traffic. And then also we have to put Ethernet 2 and Ethernet 4 under VLAN 20. So we have to go to the switch and then to the VLAN. So let's do that. So here, after we finish the configuration on the bridge, we have to go to the switch. You see, now this settings shows different than it was on the router board. Okay, so you can see that it has totally different settings over here. So now we have to go to VLAN. And now we have to create the VLAN over here. I will say, all right, for VLAN 10, that is the VLAN ID, I put on it the port Ethernet 2 and also Ethernet 3. Okay, and that's it. I will create another one, and now it's gonna be for VLAN 20. Inside this, we have to put the port, which is Ethernet 2, because it's a trunk port. It can have VLAN 20, but also Ethernet 4, because it's gonna be an access port on VLAN 20. And that's it. So that's what I need to do on the VLAN part. Port number 3 is done. Port number 4. Now we need to go to the egress on the VLAN tag and let VLAN 10 and VLAN 20 pass via the trunk. So if we go from here, we see that there is an egress VLAN 10. What does it mean here? So if you want, I can go to the picture here, and over here, the egress means when it is going outside the interface. Okay, so I'm gonna say that on this switch here on Ethernet 2, I'm gonna say that let's consider that the VLAN 10 is the red color and VLAN 20 is the black color. So I'm saying here that the VLAN 10 and VLAN 20, when they leave the switch, so they leave from Ethernet 2. And that's why I need to say that Ethernet 2 is a trunk port, because when the traffic is leaving Ethernet 2, they will be tagged for VLAN 10 and they will be tagged for VLAN 20. Okay, of course it depends from where they are coming. If they are coming from VLAN 10, will be tagged for VLAN 10, and if they are coming from VLAN 20, they will be tagged for VLAN 20. So that's what is the egress. Egress means from the port to forward. Okay, so that's what we need to do, and that's what they are saying us to do here, that on the egress VLAN tag, let VLAN 10 and VLAN 20 pass via the trunk. Okay, so we will allow VLAN 10 and 20 to pass via the trunk. Let's do that. So we go here to the egress VLAN tag, and from here I'll make plus. And from here I have to say, on VLAN 10, the tagged port for VLAN 10 is Ethernet 2. Okay, and I will make another one for VLAN 20. This is the VLAN ID. The tagged port, that means the trunk, it's also Ethernet 2. So that's what you need to do on this side. Okay, port number 4 is done. Port number 5. Now go to the in VLAN, and so that is an ingress, means the traffic which is coming to the port. Okay, egress is leaving the port, ingress is coming to the port. And make Ethernet 3 an access port for VLAN 10 and Ethernet 4 an access port for VLAN 20. So if I go back to the picture here, what they are saying now here is that any traffic which is, we said that VLAN 10 is the red one. So any traffic which is coming from the customer 1 to Ethernet 3, that's the way into the port, then here the port has to tag it as VLAN 10, because remember that this port on VLAN 10. So when the traffic is coming to the port, then it will tag it. When it leaves the port, it will remove the tag, and that will send it to the computer, because the computer doesn't understand tag anyway. Okay, so when it comes to the port, it is tagged by VLAN 10. And also over here, when it comes to Ethernet 4, so that's the ingress coming to the port, then it will be tagged as VLAN 20. Okay, so this is what we need to do now. So we go to the Winbox, and now we have to go here, the ingress. So I will create now one here, and I will say here, the port, which is on Ethernet 3. Then over here, what you can say, you can put, if you want, customer ID 0, or you can keep it blank, no problem. And now you can say the new customer VLAN ID is 10. Okay, so here that's what you need to do to be able to say that any traffic coming to the port Ethernet 3, it has to be tagged by VLAN 10. Also over here you can put, for example, untagged or tagged. So that's also possible. All right, and over here you can put the customer ID 0. So that's also works. So if you want, we can make it like this, or if you want, you can just put any. So that's what you need to do. And let's try to put, for example, customer ID 0 now. And this is the new customer VLAN ID. And then I will say, okay, so this is for VLAN 10 on Ethernet 3. And then we make also on Ethernet 4. And let's try now to do the untagged or tagged. So just to show you that also this works. And here we put the new customer VLAN ID is 20. And I will say, okay. So now I have said that any traffic coming from the customer 1 to Ethernet 3 will be tagged as VLAN 10. And any traffic coming from customer 2 to the Ethernet 4 will be tagged by VLAN 20. Port number 5 is done. Now, port number 6, we have finished the configuration. What we need now to do is to enable the VLAN filtering. So once you enable the VLAN filtering, and if you are connecting your cable on Ethernet 3 or on Ethernet 4, you will lose connectivity to this switch. Okay, because by enabling the VLAN filtering, then in this case the VLAN are working, and then you will lose connectivity to the switch. So that's why I recommend that you put your cable on interfaces on the switch which are not VLAN 2 or 3 or 4. Just put it somewhere else. Now go to the switch, then setting and enable VLAN filtering by putting Ethernet 2, 3 and 4 on drop if invalid VLAN on ports. So the last point that we need to do is just, we finish from here, we have to go to the switch. But now we don't go to the VLAN, we go to settings. And from here, you have generic, you don't do anything, you go to the VLAN. And now on the VLAN, they said here that if you have to put here, drop if invalid VLAN on port. So this one, drop if invalid VLAN on port. You just say that if there is no VLAN on Ethernet 2 and on Ethernet 3 VLAN tag and on Ethernet 4, then just drop the traffic. Okay, so that's what makes the VLAN filtering enabled. So that's what you need to do. Some people don't like to put the trunk port here on this one, because they may be using an untagged VLAN for the management to go to another switch. So it depends on you. MikroTik recommend that you put all the ports, but some people like to put only the access port. But let's just follow what MikroTik recommend on wiki. Okay, so this is what we need to do, and then I will say here, okay. Point number 6 is done. Now we have finished the configuration of the VLAN. So this is how you can configure VLANs on CRS. You can see that it's totally different than what we have seen on the router port. Now we need to do the experiment. We have to put the cable of the PC on Ethernet 3 and check if it receives an IP and can connect it to the internet. All right, so I will move the cable now, and I will put it on Ethernet 3. So this is now Ethernet 3. I just connect it to Ethernet 3. And let's check if I have the DHCP enabled on my computer. So actually it is, because I see that I just got connected. And if we look to the status and we go to details, you can see that I have received directly an IP of 10.10.10.254 and the whole other configuration. And I'm sure that now if I go to the command prompt and I ping, for example, google.com, here we go. I'm now connected to the internet. So this is done on Ethernet 3. Port number 7 is done. Port number 8, now we need to put the cable on Ethernet 4 and we see what IP we get and if we are connected to the internet. So I'll move the cable from Ethernet 3 and I put it on Ethernet 4. So now I'm connected to Ethernet 4. Let's go again to here and check if we are going to get an IP. And it looks like we have been connected, and we can say here status. And over here, if I go to details, and indeed, you see 10.20.20, so that's because of VLAN 20. So 10.10.10 is VLAN 10, and 10.20.20 is VLAN 20. And if I'm now going to the command prompt and I will try to ping Google, so it is now working the internet without any problem. So this is how you can create VLANs on the CRS. And you have seen that once you want to make the port access port, that I showed you two different ways how you can do it, and both of them they worked without any problem. Port number 8 is done. Port number 9, while the PC cable is on Ethernet 4 on CRS, so it's still on Ethernet 4 on the CRS. Can you connect to the switch? If not, say why. So let's try. So I will go now to Winbox, and from here let's have a look if we can connect to the switch. So this is Winbox open. I'll move it to here. So what I see now, I see the main router. I can connect to the main router because remember, this is the gateway for the PC now. Okay, 10.20.20 is the gateway, but the main switch, it doesn't show up over here. And yeah, because we have enabled the VLAN filtering, so you can see that if you want now to get access to the switch to make some configuration, change the VLAN, you cannot do that. So what I need now to do is to move my cable. So if I take now the cable out from Ethernet 4 and I put it, for example, on Ethernet 8, which is not part of the VLAN because we put Ethernet 2, 3, and 4 only on the VLAN and the trunk and the access. So I just put it on Ethernet 8. And now if I make refresh, if it's on Ethernet 8, yes, I can see the switch. Okay, because Ethernet 8 is outside all the VLAN, so it's not in the VLAN filtering. But if I put it back on Ethernet 4, so you can see now it is on Ethernet 4, and if I make refresh, I don't see anymore the switch. I should be able in a moment to see the main router, so I can see the main router. So that's the reason why I cannot connect to the switch, and that's a big problem because you know, we need also to configure the switch, sometimes change the configuration, make monitoring, do troubleshooting. So if we don't have access to the switch, that's a very big problem. So they're saying why? Because the VLAN filtering is enabled. So what is the solution now? Because, okay, we know the problem, but what is the solution? The solution is to create a VLAN management on the switch. So that's why I would like to make another lab to continue this lab. And in the upcoming lab, I'm just going to show you how you can create the VLAN management in order to be able to gain access to the switch when you are connected to Ethernet 3 and Ethernet 4. Again, I will do a lab to do VLAN management to gain access to the switch when I'm connecting my PC to Ethernet 3, which is on VLAN 10, or to Ethernet 4, which is on VLAN 20. Port number 9 is done. And with this point, I just showed you how you can configure VLANs using the cloud router switch, the CRS. So that's a very nice switch that you can use from MikroTik. And you can still use the RouterOS, so it works on the RouterOS Series 100, Series 200, but also Series 300. But on 300, you can also use the Switch OS if you want. So this is how you can configure the VLANs on the CRS. And I just showed you everything about it. Now what is still missing is to do the VLAN management, and that's something I'm going to do it in the upcoming lab. So I hope that this lecture was informative for you, and I will see you in the upcoming lecture. Hi there, this is Mar Haddad here again. In this lecture, I have to show you how you can create the management VLAN in order to gain access to the switch In case you are on a VLAN, for example, if you are connected to VLAN 10, so you are a computer connected to the Ethernet 3, or on VLAN 20, you can still gain access to the switch if you want to change configuration, do monitoring, do troubleshooting, or whatsoever. Okay, so as you can see here, we have 10 points to do, but before I start doing those points, I will go back to the lab scenario, explain what we need to do, and then come back to the points and start doing that. So this is our lab scenario. I didn't change anything. At this moment, my computer is connected to Ethernet 4, as you can see now on the switch. So it is connected to Ethernet 4. It has internet. I didn't touch the configuration. I just started recording this video directly after I finished the previous video. So what I need now to do is that from anywhere, from if I'm connected to Ethernet 3 or Ethernet 4, I can still be able to connect to the switch. So that means I need to have an IP on that switch. Okay, now what I need to do is to create a VLAN management. I will call it VLAN 50. Okay, so I just make a VLAN 50. I have to make it on the main router, because what's gonna happen is that once you put an IP over here, then if you want to connect to the switch, the traffic will go from here to the switch, and then the switch will send it to the router. And here the router is acting like what we call it router on a stick. So what he can do, because the VLAN are coming from here, from VLAN 10, and he's saying I want to connect to that IP which is on VLAN 50. So what the router will say, okay, it's another network. VLAN 10, it is 10.10.10. something. VLAN 50, you will see it's going to be 10.50.50. something. So it's another network. Then what it will do, it will say, okay, that's fine for me. I will redirect you. So we make the routing and we'll send it to the switch via the Ethernet 2. So you can see that the access to the switch on the VLAN 50 that we are going to create it, and I will show you all the details in the lab, it's going to be routed. So it has to go to the main router, and then the main router will send it to the switch, and then you can gain access to the switch. So this is the whole idea. If it's not very clear now for you, I will go for the lab and I will do it point by point. Then I will come back to this scenario to show you what I'm doing, and then in this case you will understand it, and we will see at the end that even if you are connected to Ethernet 3 or Ethernet 4, we will be able to connect to the switch also. So let's go now back to the points and start doing that. Point number 1. The main router and the CRS switch have still the same configuration as per the previous lab. So I put the picture here, and we know that we didn't change anything on the configuration. So this is done. Now, go to the main router, create VLAN 50 as a management VLAN and under Ethernet 2. So what I need now to do, if I go to the picture here, I just have to go now to the main router, this router over here, and I have to create VLAN 50, and I put it under Ethernet 2 because that means it is the trunk. Okay, so that's what I need to do now. So actually my cable is connected to Ethernet 4 still. That means I can connect now to the main router. So let's do that. I'll go to Winbox. And from here, you see that the main router is showing up for me, 10.20.20.1. I connect to it. And now I have to go to the interface. And what I need to do, I just have to create a VLAN. So I create a VLAN. We can call it VLAN 50, and I will say management. So we remember that that's for the management. And we put for it a VLAN ID, which is 50. And the interface is going to be under Ethernet 2. So Ethernet 2 is part of the VLAN at 50 because it's a trunk port. And then you can see that this VLAN 50 is being created here. Point number 2 is done. Point number 3, we need to put an IP, because once the PC is sending the traffic to go to the IP of the switch, it has to go to the router, and then the router has to have IP connectivity with this switch. So that's why you need to put an IP on the VLAN 50 of the router. So the IP will be 10.50.50.1. All right. So we go to the main router, we say IP address, and then I will create 10.50.50.1/24, and here we put it on VLAN 50. Okay. So that's the whole things that you need to do on the main router. Creating VLAN 50 to be VLAN management and put an IP address on it. Point number 3 is done. Point number 4, go to the switch, and from the switch go to VLAN and create VLAN ID 50 with port Ethernet 2 and switch 1 CPU. Okay. Now, because I'm connected now my cable to Ethernet 4, I cannot gain access to the switch because it is on Ethernet 4. So you can see if I make disconnect, the only thing I can access to is the main router. So I will move my cable from Ethernet 4 and I'll put it on another Ethernet which is not 2 or 3 or 4. So in my case, I just put it now on Ethernet 8 to be able to gain access to the switch because Ethernet 8 is not part of the VLAN. So now I see the switch is showing up. I will go to it, and here they are saying to us is to create a VLAN ID which is 50, and we have to put the ports Ethernet 2 and switch one CPU on it. So what does it mean here? Let me first do it and then I will explain to you what does it mean. So let's reconnect to the switch. It looks like I lost connectivity. So we go to the switch again, and from here I have to go to the switch and I have to go to the VLAN. And from here we have to go to the VLAN. On the VLAN here I have to create a VLAN ID 50, and that's the one which is gonna be used for the management. The port, of course, Ethernet 2, because it is the trunk port. But then they said put also switch one CPU. What does it mean here, switch one CPU? Here it's saying that the traffic has to go to the CPU of the router, so it's not part of the hardware offload anymore. Because anyway, VLAN 50 it has to go to the main router, so that means it doesn't go anymore in the switch chip, which is inside the switch. Then it has to go now outside. That's where we can say that we put switch one CPU. That means this is going to be sent to the CPU to be able to leave Ethernet 2 to go to the main router. And then I will say here, okay. Point number 4 is done. Now, point number 5, we have to create a VLAN 50 interface and put it on the bridge interface. So also on the switch, I have now to go here on the interface because we need to put an IP on VLAN 50, and we cannot put an IP unless we create a VLAN 50 interface, because this IP we need to use it to connect to it, correct? So what you need to do here, you create a VLAN and you name it VLAN 50, and here VLAN ID 50, and here they're saying you can put it on the bridge. So you put the VLAN on the bridge 1. Now you can put it on the bridge, but also you can put it on Ethernet 2. Actually, Ethernet 2 is inside the bridge, so any of both cases can work. So they said put it on the bridge. I will leave it now on the bridge, and you can see that VLAN 50 is showing up here on the bridge. Okay, so because now we need to put an IP on this VLAN to be able to get access to it. Point number 5 is done. Point number 6, put an IP address on VLAN 50 of 10.50.50.2 and create a default route to the main router. Okay, so again, just as a review what we have done on the switch, we have created here the VLAN and 50, and we said that it is part of Ethernet 2 and the switch 1 CPU. And then I have created VLAN 50, I put it on here under the bridge, and now we need to go to IP address and give it an IP, the VLAN 50, which is 10.50.50.2. Remember, it should have the same range as on the router. Okay, so on router we have 10.50.50.1. Here we put .2/24, and we put it on VLAN 50 because this is the IP that I need to gain access to it to be able to access to the switch from my PC when it's connected to Ethernet 3 or to Ethernet 4. And then they are saying to make a default route. Why we need to make a default route? Remember, if you go back to the picture here, once the PC is on VLAN 10 sending the traffic here, so this is VLAN 10, then to the switch, and he wants to go to the IP of the switch 10.50.50.2, which is on VLAN 50. Then the switch will send it out the Ethernet 2, but it has to send it to the main router for the main router to make the routing back and send it to here. Okay, so in this case we have to make a default route to say that any traffic has to go to the main router. Okay, so we just say for the switch that to go to anywhere, send everything to the main router. So this is what the default route is for. So that's what we need to do here. We go to the IP and we go to routes, and from here I would say to go to anywhere, send it to 10.50.50.1. So this is accessible from VLAN 50. You can see it's reachable via VLAN 50. All right, so we are sending everything to 10.50.50.1. And now if you want, from my switch, if I ping 10.50.50.1, you can see I have a reply. So the switch is able to see the main router. Point number 6 is done. Point number 7, ping from CRS to 10.50.50.1. Do you have a reply? We have tried it. Yes, we have reply. Now we have to put the PC cable on Ethernet 3 of the switch and try to ping 10.50.50.2 to check if we have reply. Let's do that. I'll move the cable from Ethernet 8 and I put it on Ethernet 3. So this is now connected to Ethernet 3. First, let's have a look if we received an IP from the range of 10.10.10. something. So that's something we have to check it on our network card. So if I go to status, and from here we go to details, yes indeed, 10.10.10. something. So it's connected to the internet, my PC, so everything is fine now. Now let's try, I have 10.10, okay? Let's try to ping 10.50. Let's have a look. So if I go now to the command prompt and I say ping 10.50.50.2, that's the IP of the switch. And here we go, you can see I have reply. So what's happening now is that, if we go back to here and let me clear it a little bit so we can understand what's happening over here. So the PC, which is on Ethernet 3, it has 10.10.10. something because it is on the VLAN 10. So it wants to go to the IP which is on this switch, which is 10.50.50.2, correct? So those are two different networks. So what's going to happen now? It will send this to here on this switch. The switch look and say, oh, you want to go to 10.50.50.2. That's my IP on VLAN 50, but I cannot, I'm a switch, I'm layer 2. I cannot let you come directly to me. So we need to go via a routing. He would check, how can I send it? He would see, oh, it's saying Ethernet 2 and switch 1 CPU. That means it has to go to the switch, to leave the switch to go to the main router. He would say, okay, that's fine. So I will send this to the main router and say to the main router, this guy wants to connect to me, which is 10.50.50.2, which is on VLAN 50. Then it comes to the router. The router will say, oh, that's to VLAN 50. I have also a VLAN 50 here, and it is on my trunk on Ethernet 2. So I will divert it back to you, and then I will make a routing here. So the routing happens over here from 10.10.10 to 10.50.50, and then it would be able to reach the switch. That's why you have a ping reply. So you get the idea what's happening over here. So this main router is acting what we call it a router on a stick. Okay, so he makes the inter-VLAN between the two VLANs, the inter-VLAN routing. All right, so now that means if I have ping, so let's go to the Winbox, and you can see it doesn't show up the neighbors, but for the switch. But if you try 10.50.50.2, which is the IP of the VLAN 50 on the switch, and I enter, and here we go. I'm connected to the switch now. Then this is what I need to have access to the switch, and that's what we call it the VLAN management. So now I'm connected to the switch without any problem. Port number 8 is done. We have made the ping, we have reply, and port number 9 is done also. We connect to Winbox and it's working without any problem. Now we have to do the trace route from PC to 10.50.50.2 just to show you that how the packet is flowing to the switch. So let's do that. That's a good idea. It should show me that it's going to the router and then coming to the switch. So let's do that. From my PC, trace route to 10.50.50.2. And then I will say enter. So look, the first hop, the first access, it has to go to 10.10.10.1, which is the main router, and then the main router will send it to 10.50.50.2. So you can see it has to go to the main router, and then the main router send it back. If I move now the cable from Ethernet 3, I put it on Ethernet 4, just to also check if also Ethernet 4 is the same. So now I put it on Ethernet 4, and we should be able to get an IP on Ethernet 4. So it's identifying, yes, we have an IP. And now if I go to the command prompt as we are here, I'll say ipconfig. We should receive 10.20.20. Yes, that's what we have. If we make ping to 10.50.50.2, yes, we are able to reach it. If I open Winbox and I connect to 10.50.50.2, I'm able to go to the switch. And the last thing is to do the trace route. And we also shall see that it has to go via the main router and indeed to the switch. So yeah, this is how you can configure the VLAN management on CRS. You can see it's really a nice way to be able to gain access to the switch in case you are connected to any of the VLAN. The last thing that I want to show, and which is not part of this lab, is I told you here on the VLANs that you can create the VLAN 50 under the bridge, but also I said if you put it on Ethernet 2, because that's a trunk port, that also will work. So I put it on here on Ethernet 2, and then I will say okay. So now the VLAN is on Ethernet 2 on the switch, and if I go back here and I make ping, you see that it's also working. So you can put it on the bridge, and also you can put it on the Ethernet 2. Point number 10 is done, and with this point I have showed you how you can make the VLAN management to be able to gain access to the switch, because yeah, I mean, we are network engineers and we want to gain access to all our products. So we don't want that in case we just connect to a VLAN, we lose the access to the switches. So we want to keep having the access to the switches, and this is how you can do it, creating VLAN management, and then the route will happen via the main router, and then you can gain access to the CRS without any problem using this way that I have showed you. So this is what I wanted to show you in this lecture. I hope that it was informative for you, and I will see you in the upcoming lecture.
Hi there, this is Marhaddad here again. In this section, I have to show you how you can create the VLANs on the SwOS. So SwOS is an operating system from MikroTik, but it is mainly for the switches that MikroTik do. And I will explain to you in which products you can have access to the SwOS, because not all MikroTik products you can use the SwOS. So I'm going to show you on which products you can use the SwOS. Then I'm going to show you in a lab how you can connect to the SwOS and create the VLANs, because creating VLANs on the SwOS is totally different than creating VLANs on the router boards, as we have seen before. So this is the mission of this section, is to create VLANs on the SwOS. And of course, we are going to use the same lab scenario, which is having a MikroTik router distributing the internet, and we have to create the two VLANs in order for the two other customers to receive the internet from that router. So this is what we're going to do. If you are ready, let's go directly with the first lecture of this session.